Here's our agenda for today. We are going to have a guest speaker from Allergan Foundation. It's a pharmaceutical company. And he's going to talk to us about his work in global clinical study. We have, I think, one student who's working at Allergan for the practicum, but there are in this class, there are several students who have done their practicum there and in other sections of the course. So he has a relatively long presentation. I think he went over to AirB, and he'll be here shortly. And then we will discuss, as usual, some of the cross-cutting themes in his presentation. And I'm hoping also to give you a little bit more tips about your assignments, particularly the grant proposals. So while we are waiting for him, here are some of the issues that came up last week. We had a guest speaker, Miss Diane Hall, who came from the Human Resources Office at UC Irvine. And she talked to us about the wellness program that she oversees for that office. But it was also May Day, which is the day that workers all over the world celebrate labor and the benefits and the resources available to employees of all corporations and the occupational health issues that are associated with working. And I remember we talked briefly about the occupational health agencies in the United States that oversee workers' rights and benefits with respect to health. So what are these agencies? Come on in. Sorry about that. I was just waiting for you. Yeah. We did say we'll meet in my office, but I wasn't sure. Please have a seat. No, we'll call you. So, anyone remembers occupational health agencies? Yeah. OSHA. Okay, spell it out. OSHA. Okay. Occupational Safety and Health Administration, right? OSHA. Yeah. Yes. NIOSH. In spelled. Okay, thank you. So what's the difference between NIOSH and OSHA?
Well, I think NIOSH is more like on the research aspect.
Absolutely.
Of health.
And OSHA does?
More of like the environmental health.
They do enforcement of laws, guidelines, and monitoring to make sure that people comply, right? So one does research to set the standards and the guidelines, the other one does the enforcement. And what are the two leading causes of morbidity and mortality among workers?
I don't know, I think.
It's all right.
Lower back pain, morbidity?
Morbidity, I would, lower back pain is a serious one. I wouldn't call it the leading cause. Okay, what's the leading cause of morbidity worldwide?
Or morbidity?
Yeah, of illness. Yeah, morbidity is illness. We talked about it the very first. What was the Diane Hall's main message about wellness? What kinds of health conditions are prevented? What was the focus of the office? Maybe it's a different class she talked to. So if you're asked what's the leading cause of illness in the world today, as seniors in public health, you would draw blanks, just eat your lunch and pretend you didn't hear the answer?
We talked about mental health.
Mental health, neuropsychiatric conditions, worldwide, because people don't typically die of mental diseases. They live long with it. And we have an index we call the disability adjusted life years that we use to compare different diseases. And the short for that, it's DALYs, and it's the highest for neuropsychiatric conditions. Depression creates a lot of impact in the public health sector that we don't quite know how to prevent. And so people live very long lives with it, but they are not contributing as much to the economy. And the same is true wherever sector you're looking at. So in occupational settings as well, it's one of the leading causes of morbidity. So absences from work or just performance at very low levels is almost always due to mental health conditions. So what about the mortality? What kills people most in the world?
Heart disease?
Yeah, cardiovascular diseases are responsible for the largest number of deaths, primarily because a lot of people who grow old, ultimately that's one of the conditions that get people, even if they supposedly die of old age. If a physician were to do the evaluation, that might be the cause of death they write down on paper. And among workers, however, people work, the working life is typically before they die of cardiovascular diseases, right? So most people retire. So what would you guess would be the leading cause of mortality among workers?
Accidents?
Injuries, yeah, very important. Okay, so this is just a revision of where we were. Okay, well, we're thrilled that you're here. Thank you so much. I am delighted to introduce Dr. Doan. He's at home in public health. He has a Master of Science in Public Health and a doctorate in epidemiology. And he's Senior Global Clinical Study Manager at Allergan. He sent me a very impressive biography, but then he said part of it will be in his talk. So I'm going to let him say a little bit about his background, and we can ask you questions as you speak. We'll also try to make room at the end. And he's giving these kinds of presentations to several groups, including our colleagues in the pharmaceutical sciences. And this is a very, very important area of public health, and we're looking forward to interacting with you. Thank you so much. Sorry.
Apologize. Apparently, a lot of students do not know where the social science lab is. I had to ask 20 people to try to find. And I've walked up 75% of Ring Road Circle, or whatever you guys call this here. So my name is Doan, and as Delia has mentioned, I do have a couple of degrees, but I came here to talk to you guys about clinical research. I work for Allergan now, and so actually let's just go. I'm going to talk a little bit about me, possible internships or careers in clinical research, and actually just talk about clinical research in general. So I work in clinical research now. I actually teach third-year pharmacy students at USC. I do the certificate in clinical research program at UCSD Extension, and so now this is my first venture to expand here to UC Irvine. So if you have any questions, please let me know, and feel free to stop in between. I'm going to give you a couple of caveats. Number one, I really am passionate about clinical research, so when I start talking about it, I don't realize it, but I start to talk really fast about it because I get really excited. Just let me know, and I'll slow down. Number two, this is for you guys, so stop me at any time and ask to clarify anything, because sometimes I'm so used to presenting to biopharm conferences where they already feel that some of the stuff, they want to go to the advanced stuff, or third-year pharmacy students already understand some of the pharmacological stuff, so they want to go more in depth. If you need me to scale back and explain something, then just ask, okay? But we're going to go over all these things, and I'm going to hopefully weave in some interesting stories to see if I can excite you guys about a possibility of looking for an internship or possibly even a career in clinical research, okay? For me, I got my bachelor's degree in psychobiology at UCLA, and the emphasis was on learning and memory. Then I got my master's of science in public health with emphasis on sensory integration. That's how your 5 senses take into account the external stimuli and process it in your brain, because it's a lot more than just smell and touch, taste, of that nature. And then the PhD is in public health and with emphasis in epidemiology. I started working at the UCLA Family Project on schizophrenic and manic depressant bipolar patients, and that's actually how I got my foot in the door in research. Afterwards, I actually went for a little while at the McDonald Research Laboratory in LA working on animal studies. So I actually did stereotactic surgeries on rats like this, and I actually performed the brain surgeries to insert different cannulae to either insert or extract different neurotransmitters out of the brain, either like the nucleus accumbens or the amygdala. And we were actually trying to prove that a certain medication can outcompete the dopaminergic pathway for cocaine. So if somebody was overdosing, in theory, you can inject them with this, and then they can allow them to, their body to naturally process the cocaine out without having the increased heart rate, the overdosing effects, if you will. Okay. But for me, I mean, animal research was cool, but you know, I wanted a little bit more people interaction. I actually then ended up working with GlaxoSmithKline. If you've ever seen the commercials for the Advair discus inhaler, I actually helped get that approved. It's the purple discus inhaler. The commercial is like a bulldog running around. The owner's trying to chase it around. And then since then, I've been at Allergan. I've worked on skincare products, ophthalmic products, the eyelash growth products, Botox, and things of that nature to try to get those products approved. Okay. And so just so you guys are aware, how this relates to what you guys are doing is obviously there's an internship practicum that you guys have to do. Allergan is one of the possible locations that you can do the internship at, and we have 3 different types of internships. We have clinical research, environmental health and services, or EHS, and then human resources. Okay. And I believe, and in the electronic and the paper catalog that I've seen, there's different contact folks. I mean, actually for EHS and clinical research, it's me. It's directly me. And then we have a separate person for HR. But we get the UC Irvine applicants all the time. So just let you guys know if you guys are interested in any of that. Okay. But what is it that we actually do? You know, because when someone told me about clinical research a number of years back, I was a little bit confused as well. I'm like, I've been in the lab, I did the lab coat thing, you know, there's so much more to that. So yes, I like to think of it as 3 buckets, okay? There's the animal bucket, or preclinical research, if you will. So it's a lot of test tube stuff, animal stuff, and whatnot. Then there's human research, which is what I currently do now. And then after you get the drug approved, there's what I like to consider post-marketing and sales. Now these are very broad buckets, okay? And each one can be cut into smaller sections, but just understand animal, human, and then sales and marketing completely different. Because I get that question all the time, because a lot of times I usually just think that it was only animal research. Then when I got into human research, every time I say I work for a pharmaceutical company, people always assume, oh, I must do sales. Actually, and so we're very territorial of what it is that we do. I don't want to be associated with salespeople because I do human research. And then the animals people don't want to be associated with human people, and we don't want to be associated with animal people, so it's kind of territorial. Okay? So what is it that we do? All right? So typically Monday through Friday, I'm working in the office 9 to 5. People think, what, are you just buried under a pile of paper? There's actually a little bit more to that. Okay? I communicate with doctors. I'm organizing. I actually design studies. So remember in the 3rd grade when you had to do a scientific project, right? And you had your poster board, and if you were fancy, you had like a tri-poster board, right? And you had like observations, and then your hypothesis of what you think would happen, and then how are you going to do it, right? You said, well, these are my materials, these are what I'm going to do, and then results and discussion, right? And maybe some cool picture. If you had the tri-level, you had some cool picture right here, right? Okay, so imagine that, but times 100 pages. That's what a protocol is. So if I design a human study, obviously there's a lot of wacky things that can happen, and there's a lot of observations that happen in real life, right? Different drug-drug interactions, previous studies that we've done, studies that somebody else, a different company has done. Sometimes investigator-led studies that have no connection with Allergan have done studies and published them. We reference these things, so that's our observations. Then we think, hey, we see all this cool stuff. Maybe this drug will work in a certain disease. Hypothesis. Well, how are we going to prove that? Materials and what we're going to do, right? And then once it's done, so that's the protocol. And then actually you run the study, and then when it's done, that's your results and discussion, right? But our results and discussion is like hundreds to, if not thousands of pages, because we slice and splice the data every which way. But it's basically your science experiment in the 3rd grade, but times like, exponentially 100, I do a lot of mentoring and training. So like I said, that's why I'm here with you guys. We mentor the interns. We have residents from pharmacy school and medical school come to Allergan, so I mentor all of them. I also just do a lot of training of all new associates that get hired at Allergan. I actually train them on clinical research, so I give them something a little bit more in depth than what I'm going to give you guys today, but I use some of the similar slides. You can get published. I worked on a certain disease where there's no questionnaire, quality of life questionnaire at all for this particular disease because it's a rare disease. Just last year, for the last 5 years, I've been working on it, getting it used and validated. It actually got published and it's out there. So if you have a particular disease called atopic keratoconjunctivitis conjunctivitis and your doctor says, hey, you need to answer this questionnaire, it'll be the questionnaire that my name is on. So it's kind of cool. You can get published. But there's other, you can get published in the journal articles, like some of these articles that you've been reading when you guys are writing your papers and things like that. But you're also working to improve the quality of lives of others, because ultimately the end goal is to get something approved that actually fixes a disease or helps patients or improves their quality of life, right? So that's in a nutshell. But it's not, doing all of this is not just sitting in an office, if you will, okay? Obviously, if you do the internship, for legal purposes, we cannot send you all over the world, okay? We would love to, but you'd probably be working in the office with someone like me, shadowing me, mentoring me. I mean, I would be mentoring you, and I'd probably give you some cool stuff to do. I'll probably get, and try to get you exposed to clinical research. But there's also a travel aspect. So for my particular job, I've actually traveled all over the world. In 3 years, I've been traveling since 2002. And I went all over the US and then Canada. I've been to India several times, Australia, Europe, Asia, Egypt, Jordan, you name it. In 3 years, between 2009 and 2011, I actually filled up my entire passport from cover to cover. I actually got in trouble because I got pages stamped that you're supposed to leave at the end. The cover is supposed to be blank, and I got that stamped, and I didn't know any better. But then when I came back, the US Customs said, you're not allowed to do that. That's illegal. I didn't do it. They blame Egypt, okay? But just know that if you don't want to travel, if you don't like to travel, and there are some folks that have concerns about what if I have kids, what if that, you can always cater it such and do US-based studies. I actually like the emerging markets, so I specialize in the emerging markets. And I told my boss that I was willing to sacrifice my time to go to all these places, to not sleep in my bed, to not eat my own food, to have to experience all these different cultural things to find these patients all over the world. That's the sacrifice that I was willing to make for the company. So you can see how awesome they think I am, right? Okay. So that's some of the stuff that I've done. And how do we get there? Obviously you guys can do an internship. There's also rotations, like I said, for medical school and pharmacy school students that have come through. We also offer fellowships 1 or 2 years. That's like after you finish your PharmD, Ph.D, or MD, you can do a 1 or 2 year fellowship. There's certification programs. I told you I teach the UCSD Extension Certification Program. There's also other ones, and I think UC Irvine is actually even coming out with something in clinical research, right? A master's in clinical research or something. Any postgraduate degree will help, but it's not required. Obviously any master's or PhD or PharmD, MD will help you and move you along. But it's not required. A lot of folks that I work with, even when I first got my foot in the door, I just had the bachelor's degree at the time. And that's possible. And I say this because I, at one point, was like you. I was thinking, do I go to dental school, pharmacy school, this, PhD? I'm not sure. I was a little undecided. And you ask 90 to 95% of the people in clinical research, they will tell you they fell into it by accident. And I was just asked by a friend, because they knew I was good at science, hey, do you want to try this? And I said, well, I'll do it to save money for my med school applications. But then it actually turned out I really liked it, and I was actually really good at it. And then my company paid for me to get my master's and PhD, so I was like, well, I have no debt. I'm making money while they're paying me to go to school, and then I finished with no debt. That's like a win-win-win situation, right? So I just kind of just did it that way, but I actually ended up really liking it, So I love what I do, and that's why now I want to get the word out, because when I was an undergrad, I had no idea that this ever even existed. So that's why I do these presentations that I do. There's obviously all kinds of advancement possibilities, so it's not just pharmaceuticals. Like I work on pharmaceuticals, but there's medical device, there's biotech, there's consultants. You could be office-based. One of my best friends is now home-based. I trained him for years, and then now he actually is home-based. He travels or he works from home. That's kind of like awesome, right? You could do global, you could do local, so you can cater. There's a ton of opportunities out there, but it just a lot of people know about it, okay?
Are there different tracks that getting these graduate degrees can allow you to go on as opposed to other tracks that might just...
Yes, yeah, there are certain tracks that, like, when you get to a certain level up, you might feel that you're limited. So, for example, like, if you're a medical safety physician, they typically want you to have a Ph.D. or an M.D. because obviously you're answering safety-related questions and you really need to understand the drug-drug interaction. So they'll allow some kind of doctorate, O.D., PharmD, Ph.D., M.D. Some pharmaceutical companies strictly say it must be an M.D. or a D.O., some kind of medical physician, because it depends on the safety profile. If you're working on oncology drugs, most likely you need to be M.D. D.O. At Allergan, we allow some of our medical doctors, medical safety physicians is what they're called, to be a Ph.D. or PharmD or O.D. because, as long as you can answer those questions. But also, like, when you work your way up from associates, we have associates, senior, principal, manager, senior manager. When you get to director, senior director, sometimes people feel there's a glass ceiling to it. If you want to become a vice president ever, they feel that you need a doctorate. We always see that. There are some companies that don't and some companies that do. So it just depends. If you work at a more progressive company, they don't care. If you work for one of those, the old boys club that's been around, they're like, yes, you must have a Ph.D., you must have a PharmD or something like that, and you must have this, this, and that, and X number of years of experience. But you can do any of these, and the thing is you can also crisscross. We have folks that have been in clinical research, decide to go to biostatistics or data management, or vice versa. We have nurses, epidemiologists, biostatisticians switch back and forth all the time. Okay? So there's all kinds of different related occupations, and these are all the different folks that I would work with. When I say clinical research associate, a CRA is a general term that's used in the industry, okay? A clinical research associate, and we will interact with any and all of these different departments. And you're going to work, so that's why it's you can switch and jump back and forth. To even go into legal. Why would you ever go to legal? Because in the biotech pharmaceutical company, there's a lot of patent laws, right, that you work with. So if you understand the science, but then also understand, and you get your paralegal degree or your JD, you're like a really powerful person, actually. Because there's actually a very small niche of people that understand law and science, and you're actually highly sought after. So where do we go? How do we start? How do we even get to this business of getting drugs worked on and getting it approved? Okay, so we usually start with a new chemical entity or a new molecular entity. We discover something accidentally in the lab or whatnot, or sometimes we buy it from somebody else that's already discovered it. But let's just say somebody has discovered a new chemical entity or new molecular entity. Just so you know, when I meet people and they ask me what do I do and I say I work for a pharmaceutical company, I either get, ooh, what products do you work on? Or, you work for Big Pharma. Why do you guys sell your products so expensive? Okay, let me tell you. Did you know that from start to finish it takes about 12 to 15 years to get a drug approved? And it costs about $1 billion, hence the picture of Dr. Evil there, okay? If you spent 12 to 15 years with your blood, sweat, and tears and you invested $1 billion, do you think you might want to at least break even and make your money back, okay? But you're thinking, but you should be able to make your money back after a while. What if I told you that the patent is only valid for 20 years? So if it took you 15 years, you have 5 years left to make $1 billion back. That's why the price of pharmaceuticals is the way that it is. I didn't make those laws, but it's still a business, right? We're investing this many years. We have to keep the company afloat so that we would continue to do research. So we have to make this money back and plus my salary, other people's salaries and things like that to keep the company going, right? So that's the reason why the pricing of pharmaceuticals is the way that it is, okay? Typically, and you're like, well, sometimes people say, well, you guys have a lot of products that are approved, but you just hold back, right? And you don't release it. Okay, if that was the case, because honestly, it's really hard to get something approved, because I'll tell you 2 reasons why we wouldn't do that. Number one, typically for every 5,000 pharmaceutical, new chemical entities, new molecular entities we discover, only 5 make it past animals into humans. And of those 5, only 1 gets approved. So we're talking about 4,999 failures. Do you really think I have that many in my back pocket saying, I'm going to hold this ace of spades in my back pocket until we're ready to go? And then number 2, the longer I hold it, the more I eat into this. Why would I want to eat into this time when I can make money off the, and because I'm limited in time to make money back. So those are the 2 reasons why I've never seen it. I see movies, I see conspiracy theory things about it all the time. I've never participated in it. I've never heard of anybody actually doing it. But, you had a question.
I did. The $1 billion you're talking about, is that grant money or is it money from Allergan?
It's money from Allergan. Grant money is actually really small compared to the big picture of the private sector. So we have investigator-led studies, like let's say a doctor here at UC Irvine contacts us. I have this really cool idea. I want to do XYZ. Can you sponsor us? Sure, we might throw $50,000, $100,000 his way to do it, or we might say, you know what, we will offer our product for free. You don't have to purchase it. Here you go. Here's Botox. Go have at it. Okay. And we'll check back with them to make sure that they're not just selling it on the side on the black market or something like that, because we don't want that to happen. But that's like actually a small amount. When we do these private funded studies that I'm working on, that's where the millions add to billions of dollars come in, because these investigator trials are actually, they're not that costly at all. And a lot of times they're more on animals, so that's really inexpensive. It's the human trials that are much, much more expensive. So what do we mean? So I'm going to build this 12 to 15 year timeline. Okay. This is so that way you don't cringe when I talk about animal studies, right? Because it's happy animals, right? So we're talking about, we have to synthesize the chemical, the drug, right? And we do in vitro, ex vivo, and in vivo studies. So we say in vitro, Latin for glass, in the glass, like test tubes. Ex vivo, outside the live organism, or inside the live organism. Inside the live organism meaning animal studies. So what do we mean by outside the live organism? Sometimes we're sacrificing an animal already. We get skin cell cultures, we get stem cells, we get eyeballs. You could actually perfuse a heart. You could take a heart like this and hook it up, perfuse it, add fluids to it, and keep it alive for days. And then if you have a drug that you think might cause QT prolongation or like increase heartbeat or slow down your heartbeat, you can drop the drug right onto the heart. It'll absorb through the skin cells, and you will actually visually see, does it increase the heart rate or not, without having to sacrifice another animal to do so. Because let's say this animal was being sacrificed for a different reason. And this is not new technology. This has been around since 1895. The first heart was perfused. It was a frog heart by Dr. Langendorf. That's why it's called the Langendorf assay. Okay? So just to give you an idea, all of this takes 6 years, because there are 20, okay, I'm going to keep everything in relation to the US, because if I go international, it's going to confuse you, because every country has different rules. So you cannot take what we know here and apply it over there. That's why I have to give you a basis of something first. And that's why I specialize in the emerging markets, because it's like when you go to India, China, it's completely different. Okay, I mean, it's different, but it's same, but the rules are a little bit different. So over here in the FDA, they want you have to answer 23 different questions. What's the toxicity? What's the mutagenicity? What's the carcinogenicity? Is it passed through from the sperm to the fetus? What's the teratogenicity? There's 23 different questions you have to answer. And just because it causes toxicity doesn't mean it's going to not pass. You just have to be able to assess it's on a scale of 1 to 5, or is it an A, B, C, D classification of drug. So you answer these 23 questions to be able to move into human research. Okay, so right now it's all animal, all test tube, all in vitro, ex vivo studies. 6 years. Okay, then we get approval. Then we think that we can go into humans. But it doesn't just mean, oh, I've done 23 studies. Here's my pass. I get to go. Okay, we got to do a couple other steps. All right, we need a couple of things in place to do human studies. Okay, so here's a trick question for you, because before I dive into human studies, people always ask me, well, that sounds easy then. You should know everything about it. And, or they say, how come drugs get approved, but they have all these weird side effects? And we're going to get into that, why that even happens, okay? But I want to ask you guys, because this is a real test question. If you can, there's a certification test to become a certified CRA. Okay, it's a CCRA. Which of the following is the most important factor to consider regarding the selection of a study site? Now, just to give you some reference, we are a pharmaceutical company. If we see the patients, we would probably say, hey, all the patients we reacted positive, drug works. Okay, that's a little bit biased, right? So, per international guidelines, we are the pharmaceutical company, we're the sponsor. Okay, we manufacture the drug. So we hire independent contractors who are doctors. They have a site. Their site consists of usually their private practice, or it could be UC Irvine Laboratory, or it could be Mayo Clinic, and they probably have a study nurse and sub-investigators and a whole facility to see patients. That is what we mean by a study site. They are not Allergan employees. We will hire them as a contractor to see the patients. They see the patients as a third-party observer. They collect the data. And typically when we say double masked or double blinded study, that means the patients don't know what they're getting. The doctor also doesn't know what they're giving the patient. So that way it's unbiased as best as can be. And then they give the data to us, and then we analyze it. Okay? So that's what I mean by a study site. What is the most important factor to consider regarding the selection of a study site? And there's no wrong answer. This is a circle of trust. No one will be made fun of if you get the wrong answer. I will guarantee you every time I present this, I always get the guesses of all A, B, C, and D. So before we move on to the next slide, and I don't want to stay on this slide for the next 2 hours, can you please just give me a guess and just say it out loud? I will not judge you if you give the right or wrong answer. I want to hear A, B, C, or D. We'll make this a little bit interactive, just a little bit. I've heard A, B, and D. Nobody likes C? I've heard more A's. I've heard A. I see somebody lipping B, but they don't want to say it out loud. It's okay. It's our secret, okay? All right. So I heard A, B, and D. Wow, nobody likes C. That's good. Because if you like C, then you would like D, because D is a better answer than C, because it incorporates the PI's experience. The PI is the principal investigator, by the way, versus the knowledge of the entire study staff. Well, this study staff includes the PI. So if you like this answer, then you would like D. So we can eliminate C, right? That's good. Okay. Now, also, we can always rent equipment or purchase it for the doctor, right? And or borrow an EKG machine or rent it or whatnot. So we could always eliminate that. Facility and equipment, that's always rentable, that's producible, that's, But mind you, all of these things are important, but if I had to pick one, we cannot force patients to go into a study. They have to volunteer. They have to sign informed consent. We also can't attack vulnerable populations like prison populations or females of childbearing potential or even kids under the age of 18. I mean, you can, but you have to have special approvals and things of that nature. So although this is very important, we can always train doctors and staff on things. And that's part of my job. Since I designed the protocol, I go out there and I document that I trained every single person. I'll either go out there and have a big meeting or I'll go individually one-on-one and do a presentation like this and walk you through the protocol. So the most important thing is the availability of subjects, because you can have the best protocol, best staff, best facility, best equipment, but if not one patient walks through the door, you still have nothing, okay? And you can't fabricate it, because if you fabricate it, you can go to jail, right? You don't want to fabricate data, okay? And there's been lots of cases of that, because we could talk about the bad cases of clinical research all day long, but I'm going to give you 2 stories throughout my presentation about fun, actually nice cases of where we could say, wow, the pharmaceutical company did good. Because there's all kinds of weird stuff that people fabricate, because it's actually really lucrative. Okay? Typically in the US, an average patient for a study will earn a doctor anywhere between $8,000 to $10,000 per patient. You enroll 10 patients, that's $100,000. You can enroll 10 patients in like a week. Okay? So it's actually pretty lucrative, right? And doctors will work on multiple, 4, 5, 10 studies at a time. Plus, they're seeing the regular patients of their normal practice. Okay? So now you could see why someone would want to risk fabricating data. Okay? But it actually happens a lot less than people think, because the movies have really made it look like it happens all the time, but it's actually, because there's a lot of regulation that goes on. Okay, so now what do? So we write the protocol, we figure out what doctors we want to work with, we think we know where the patients are. Okay, we have to do an investigational new drug application to the FDA. It's an IND. Do you want that door closed? Or? Okay, so we have to take all the 6 years of animal data. Okay, there's pages and pages of the pharmacokinetics, the pharmacodynamics, how we manufacture the drug, who we want to do the first human study with. We have to have the doctor's CV and have him fill out all these forms, financial disclosures to prove that he is not our Allergan employee, so we're not paying him on the side to just say, yes, our drug works kind of deal. It's like hundreds of thousands of pages. We submit that to the FDA, all right? We show all the results from previous experiments. We have to wait 30 days. They will review it. No news is good news. So sometimes you don't get a letter saying, hey, it looks good, go ahead and go. You don't hear anything, 30 days later, you can start, okay? But at any time, they can come back and say, whoa. Even if they were late, they're like, you know what, I'm sorry, we took 3 months to review this, but whoa, you need to stop. You have to stop, okay? That's up for the very first human study. So that's very significant. So a lot of times you hear that referred to as first in man or first in human, FIM or FIH. Okay, it's very significant. Then after that, you always have to, at minimum, update the FDA annually. So let's say the study's not done yet. You have to say, hey, study's not done yet, but we've enrolled this many patients. These are the side effects that we've seen. This is how many, hopefully you don't have any deaths, but this is how many deaths, this is how many serious adverse events, this is the total number of adverse events, and et cetera, et cetera. If it is done and you want to move to the next study, you have to update the FDA at least once a year, but you can update them every month if you wanted to. Like, oh, we want to do another study, and now another study. You keep submitting the next protocol and the next protocol and any supporting documentation. Okay? Now, since the first study, you have to wait 30 days. After that, any subsequent study, you can start immediately. And now most pharmaceutical companies will do a 2-day rule because you FedEx it overnight, and then you wait a day to make sure that it gets delivered to the proper person. So 2-day wait, okay? Any subsequent one. The very first one is 30 days. Any subsequent one for that particular drug is just you could do immediately, okay? So, but you might say, well, why wouldn't you, can you ask the FDA for their advice? Can you get a letter of approval saying, yes, you move forward? Yes, you can. So why wouldn't you do that all the time? That's called an SPA, a Special Protocol Agreement, because you will then say, hey, FDA, can you please review this? And we want an official letter from you. So you can get that. Well, you'll pay them anywhere between $50,000 to $100,000 for the meeting. They will put you on the books and say, we can't meet with you until about 60 to 90 days. And then when they come back, just to show that they actually reviewed your stuff, they will come back with recommendations and questions or concerns or that you have to make a change. They always will, because they want to show you that that you spent your money. It's money well spent. So they're going to give you, and they might be awesome recommendations, or it could be wacky. I'm not sure. Okay. Now you're thinking, well, that's only 60, 90 days. That's a pretty good investment for $100,000. Okay. I'm not even worried about the $100,000. Let me give you an example. A blockbuster drug, by definition, is $1 billion a year, right? You guys know that, right? Any drug that sells $1 billion a year, like PubHlth, Botox just broke the $1 billion mark last year. Okay, it just did. So it's not, it just became a blockbuster drug, if you will. But Allergan actually doesn't really have any blockbuster drugs other than Botox, and I'll get to why Botox became that. So let's say a really good drug is $500 million. Would you agree $500 million is a really good drug? Okay, let's just underestimate. Let's pretend it sells $365 million a year. That means it sells $1 million a day. If you want to wait 60 to 90 days, you just cost the company $60 to $90 million. Now do you want to wait for that SPA? If you don't have to, I would say no. But if you really need it because you're not sure, then you're sure, go for it. Allergan is primarily an ophthalmic company. We know how to do glaucoma studies. I know I've been designing glaucoma studies for years. I know I don't need the recommendation. I know exactly what the FDA wants. But if, for example, when we went into Botox for the first time, and it's kind of like new territory, yeah, we went for an SPA to get the fine lines, whatever, to get the overactive bladder, chronic migraine headache. Because by the way, Botox is approved for so many other things than fine lines and wrinkles. Those things we don't have a lot of expertise in because it's breaking new ground. You probably want an SPA for. So that's when.
The SPA, what does it give you though? Is it that after FDA gives it, they can no longer come back to you and say, no, you have to?
Yeah, yeah, exactly. So they will review it, and you will get a letter documenting saying, we've reviewed this, these are the people that reviewed it, and you can start now, but these are our concerns. But the thing is, it's a catch-22. Whatever they say is their concerns, you must address. So if they say you have to, let's say you design a study, I'm going to enroll 200 patients, and they come back and say, no, we feel that you need to enroll 500, you have to now. But they will also say, yes, we agree that your hypothesis is correct. Yes, we agree your variables are correct. So if you finish the study and statistically you show that it met all that, then they cannot say, no, we're not going to approve it because they have already pre-agreed that they would. If you meet this, we will approve it. So it's kind of like catch-22.
So it's a chance to proceed without it, but they may never get to it.
Exactly. So you get all that done. So you're like, woohoo, now we can start our phase 1 studies. Now remember, there's all kinds of rounds of approvals too. So it's not like, oh, I got the FDA approval, I'm good to go. Okay? Because if if you've ever done any research here, even if you've taken a psych course, you might have to participate or volunteer or done something. It's not just FDA approval, because they want to make sure that the scientific integrity is correct. You also need an IRB approval, right? An institutional review board approval. And they want to make sure that the safety of the subjects is looked after. That's their main concern, the welfare and safety of the subject. But it's not just those 2 approvals. And by the way, these are 2 independent agencies. There's also usually an internal approval. So my company, before I even submit it to FDA, and before I submit it to the IRB, I will internally submit it to a committee within my company, and I will have MDs and PhDers and people from different departments review it, and they will rip me a new one and say, no, you are stupid, this doesn't work, blah, 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 and I will have to fix that. So that way, we feel that this is a really strong protocol. Then we go to the FDA, and then we can go, and then if the FDA approves it, then we go to the IRBs. So it's like kind of like 3 layers of approval. You get all that, boom, then you can go to phase 1, okay? What is the primary focus of phase 1? It is the safety. Remember, all this weird stuff that we saw in the animals. So for example, Oh, and by the way, I forgot, hang on, I got two things to say about animal studies. So first of all, anything that we saw in the animal studies, we must address in the human studies. So for example, if I did a study in rabbits and I noticed that after dosing the rabbits, they all drank twice as much water than they did the previous week. Probably it causes dry mouth. I will have to include some kind of dry mouth questionnaire or some kind of dry mouth test. Okay? If I did a study with rats and I noticed that after dosing, within an hour, all the rats fell asleep, probably causes drowsiness, I'd probably include a somnolence questionnaire. It's all these things that we observed in the animal studies I would design in the human study. Because I need to answer all these questions. And I need to also answer, does it cause any rapid heartbeat, does it cause any hepatic impairment? Does it do any of these things? I need to answer all these safety questions, okay? Now, how do we decide what animals it is that we use? And I forgot to mention this on my animal slide. Okay. If you're doing an ophthalmic study, you will most likely do it in white New Zealand rabbits and beagle dogs because their eyes react more similarly to human eyes. Okay? And also the cool thing about white New Zealand rabbits is if you put an eye drop on their eye and you stare at them and they're awake, assuming they're awake, they don't have to blink. So you could just observe their eye for like 10 hours and be like, ooh, that's awesome. Look at it absorb, okay? So that way you can get an idea of how drug absorbs across the corneal membrane. But now is that real world? No, that's just to understand how it absorbs. You want real world. What's real world? You'll blink. And what happens when you put an eye drop in and you blink? Some of it tears out, right? Okay, and that's normal. So we need to reproduce that. So that's why we would do it in beagle dogs, because dogs will blink. They'll even shake their head a little bit and you'll lose some, okay? And that's normal, because then we want to see how much drug is absorbed after you lose that, okay? If you were to do a skin study, like an acne or psoriasis study, you always do mice and rats because they're super reproducible and they're super cheap, right? And you could just order like out of a catalog. I want 100, white albino rats, Sprague daily rats that are 180 grams, 180 grams, age, boom, done. Right? And genetically, they're like 99.9% the same. That's why because you want to reduce as many confounding variables as possible. So mice and rats, super reproducible. You pick albino because it's easy to then identify any hair color genetic defects. Like once you give the drug, all of a sudden it starts growing blue hair. Okay, that's easy to identify. That's why we choose albino. So you almost always do mice and rats. But then why do we pick these other larger animals? So I gave you the reason for ophthalmology, I gave you the reason for skin. If you feel that it might have hepatic impairment or liver or damage, you will do it in dogs also because a dog liver reacts more similarly to a human liver, okay? And rarely do you go into full primates, but there are studies that you need to, and there will be reasons why, because obviously, a simian is 97% similar to a human, right? So that's why you would do chimpanzees, but that's not required for all studies, and I know for our ophthalmic studies we don't need to do that, okay? So you see all these side effects, you design the human study appropriately, and it doesn't need just one. And there's not a set number. Like you remember in the animal studies, I had to answer 23 questions. But it doesn't mean, you might be awesome and do 23 studies to answer 23 questions, but it could take you more. I have to answer then all those safety questions, and it could take me one phase 1 study, or it could take me 6 to 10. I don't know, But typically it's 1 to 14 day studies. Typically 20 to 100 patients. The smallest I've done is 8 patients. The largest I've done is 150 patients. And add up all this is about 1 to 2 years. Now remember, 6 years in animal studies, plus 1 to 2 years here, so now we're at 7 to 8 years, because I'm building the 12 to 15 year profile. How is it possible that a 1-day study can take 1 to 2 years? Okay. It sometimes takes me 3, 4, 6 months to design the protocol and write that 100-page protocol. That's 6 months right there. Then I do a 1-day study. Okay. But I need to then collect all the data and analyze it and splice it every which way. That could take me another 4 to 6 months. That right there is a year. And then, of course, I'm not going to do it serially. I'll stagger them a little bit, because once I finish this study, although I'm analyzing, I can start the next one because I kind of already know, how it's going to happen and I don't need the final full, 200-page report. I can get the initial top line and realize, oh, it did work, and oh, I see these side effects. Cool. I'm going to redesign the next study, the next phase 1 study appropriately, and I start that while I'm analyzing this study, and I kind of stagger them, okay? And you add all that up, and that's how it takes 1 to 2 years, okay? Make sense? All right? Okay.
Ask a quick question.
Sure.
So at this period, you already have patented the chemical or the drug. So you're
Oh,
not
yeah.
worried about publishing these results as you go along.
Well, okay, yes and no. So yes, we've patented it. We've patented it when we identified it. And I'll get to why. So in the US, we're lucky. If somebody steals your information and submits a patent, and you can prove by emails, by timestamp, dated whatever, notes, journals, they will allow you to go back up to 1 year from the date of the patent. And if you could prove that it's actually your info, the US courts will give it to you. If we're in Europe, whoever files first wins. I don't care if you have significant evidence showing that it is yours. Whoever files first wins. So therefore, you want to be the first one to file it. And you want to be very secretive of this information, okay? So, yes, we will have filed it already. But we are still concerned about publishing all of this data because we don't want our competitors to know how we designed our studies right away. So we will publish it, sometimes we'll publish it very lightly saying, we're doing some prospective studies on da-da-da-da-da. Because stock owners want to know like what Allergan's up to, so we have to throw them a bone. But we're not going to say we designed it like this and we're doing this and da-da-da-da and these are the doctors we use. I'm not going to give yeah, exactly. I'm not going to give my competitors the blueprint on how I got this drug approved. That's my proprietary information. Okay, and so yes, sir.
So when you say it'll take you 6 months to design, is that like how much time do you devote to that, to designing that study like every week?
Depends on how knowledgeable you are on the product. So at first, let's say you know nothing about it, you're probably going to read a lot of peer-reviewed journal articles because you want to understand the disease. You want to understand what else is out there, what's the current therapy, what's the current standard of treatment. Now, if you already know that, let's say you're just awesome and you just know that already, obviously it'll take you a little faster, but I'd spend a good, out of a 40-hour week, and I never work a 40-hour week, so I work like 60, 80 hours or whatever, I'd probably spend like 20, 25% of my time on that maybe. If it's my first study and I know nothing, probably half my time on that. Like right now, I carry a heavier load than most people. I'm running 8 studies concurrently. Most managers, my level, they run 2 or 3, but I have 8, right? So I can't afford to spend that much time on it, but I also know my products really well. So it's easier for me. But the first time I got one, my boss gave me one, and I spent tons of time on it, and I really learned it really well. So now I'm actually considered the expert on AKC at Allergan, which is atopic keratitis conjunctivitis, and I could talk about that much more later. But it's a really gross disease, and if I put pictures on here, you guys probably, especially some people that are eating right now, it's not good. Won't be good.
That's a question.
Yes.
How many years typically does it take to go through all the phases and administer the drug, like on a before?
On a what?
Like on the lab, to out to the community.
Right, that was the 12 to 15 years and $1 billion about that. Okay. And so also the other thing I wanted to mention is one-day studies. Okay, this is illegal, but this has happened before, and I'm not going to give you any names. It may or may not have happened at Allergan. That's why I know this, so I cannot confirm nor deny this. But there's a thing called blink and scream studies. Now imagine you can go through 6 years of animal studies to finally get here and realize, oh man, it doesn't work, right? Because remember, it's safety. If I put one drop in your eye and it burns, I don't care if it works. If it burns, I'm probably not going to get it approved because it's not safe, right? So there's this thing called blink and scream studies. So in your chemistry labs, outside there's always those like eye flushing things, faucets that or there's a thing you pull it and it dumps water over your head, right? So there's people that are like, they'll create this formula and they think it's pretty safe because they know the structure of the chemical and they know how it's supposed to react, and there's other similar product profiles. So they say, hey, you want to try this? So they give it to their buddy. They're like, hey, can you put one, drop in your eye and tell me how it feels? I was like, I'll do it to myself too. We'll do it at the same time, okay? 1, 2, 3, go, right? It has happened, especially in the 70s and 80s. And that's why it's called blink and scream, because when someone puts it in and you hear them running down the hallway saying, oh my God, where's the water? Yeah, it's probably not going to work, But you can't ever document that. You'll just know that you're going to kill the project. You already know, Now you're not supposed to do that, and that's not publishable, okay? But man, you just saved the company 6 years, and probably lost your eyesight, okay? Now, does this happen? I will tell you, there was an employee that I trained for 6 years. Then she went on to another career at another company, and I don't want to talk bad about any other company, so I won't give you the name. But so she's working at this company, and they're working on a skincare product, like a sunscreen lotion or whatnot. So her boss is like, hey, give me your arm. She's like, oh, what? She's like this. And then the boss starts rubbing this stuff on her. And she's like, oh, is this the new like Bath and Body? Like, she's like, oh, is this the new Bath and Body lotion? She goes, no, that's our new formulation that we just made. And she's like, what? And I'm all, this is just 2011. So I'm not talking about 1970s, 60s stories. This just happened 2 years ago. And she has I trained her for 6 years. There's no reason for her to make up the story lie to me, you know? So and she's the one that called me and told me the story. So it happens. And she's heard my presentation, so she was like, hey, that you should not do that, and gave all the reasons why, you know. But it does happen, because people just want to know, quick answer. If it burns, guess what? We're going to kill the project right now. And you will also have 3rd-degree burns right here, and you will look a little funny, okay? Now, what we will do in this is we want to answer the dose range, okay? So in other words, what we give animals is 100, 1,000, sometimes 10,000-fold more than what we would give humans, because we want to push the envelope. Plus, we weigh, the ratio, our body mass to weight ratio is way more than a rat. So what we would give them is way more than what we would give humans. So then we kind of estimate, well, how low would you go in humans? And then we go even lower, just in case. So we would want to go maybe a low dose, a medium dose, and a high dose. That is a very basic dose ranging escalation. The most I've ever done is I actually had 8 steps, because I didn't know where we would fall, you know, because it was an oral drug. We also want to figure out the duration of action. And we would do that by taking blood draws. So we would probably take a blood draw before we gave you drug. Then we'd give you drug, and we'd take it 15 minutes later, an hour later, 2 hours, 4, 6, 8, 12 hours. A typical, and then we would build a typical PK profile, concentration max, area under the curve, C max, you know, all these things. And then we would figure out, well, that's how we figure out why you should dose once a day, twice a day, 4 times a day, because you realize how long it lasts in your body. And once you reach 50%, that's what's called your EC50, we figure it probably doesn't have any more therapeutic value, so you need to dose again. And that's how we figure that out. Okay? That's also how we figure out, should you take it on an empty stomach, with food, without food, etc. We also figure out how the drug is absorbed, distributed, metabolized, and excreted. That's your ADME. Okay? Now, a story here is PubHlth. You could Google this. PubHlth is a company in the UK, and they did a phase 1 study. They did all the animal studies appropriately. They passed every step of the way. They even did chimpanzees, okay? Passed. They had 8 patients, human patients enrolled. And so they dosed the patients 2 minutes apart, okay? 2 patients were going to get placebo. 6 patients were going to get drug. By the time they got to the last patient, because remember, it's only 2 minutes apart, so we're talking 16 minutes, maybe if they lagged a little bit, 20 minutes apart, right, from the first to the last, right? And I know that drugs typically take 15, 30, 45 minutes to start working, you know? So by the time they got to the last patient, a little bit later, one of the first patients started, like, their head, their hands, and their feet swelled, and it was like elephant man syndrome, like double the size. It was like really bad. They were like hospitalized, like almost died from this. Okay. Now, how sucky do you think that is for like patient number 5 and 6 being like,
That's gonna happen to me.
right? So first of all, but the thing is, like, they actually submitted this to the European version of FDA. It's called EMA. Okay. They got it approved also, and there it's more formal. Like, you will get an approval over there. You cannot start until you get this letter over there. Whereas here, you remember, it was the 30 days wait. If no news is good news. They did everything properly. They were investigated. They did all the animal studies properly. There was nothing. They weren't hiding anything, and they were actually found not guilty of anything, okay? Because they actually did everything properly. So what happened there? Well, first off, you know, chimpanzees are 97% similar to humans, genetically wise at least. There was something in that 3% difference that reacted violently, that we have, that chimpanzees don't have. So there was no, that's why in the court, it was like there was no way, you could have done 1 million animal studies, you would have never gotten that reaction because they do not possess whatever neurotransmitter it is that we have, because it was in that 3% that's different. And that was scientifically proven, okay? Number 2, I probably, in general, space my patients out 10 minutes. Why? Because I know it's good. I space it out depending on the T1 half, but usually T1 halves it's covered by 10 minutes. But if it's longer, then I'll go longer. Why? Because if I go 10 minutes, mind you, by the time I got to 20 minutes, I would have only dosed 2 patients, and I would have seen that reaction in that study, right? Because remember, by 16 minutes, they saw the first patient, and they're like, holy crap. And you can't take the drug out of it. You've dosed all the patients already. I would not have spaced it 2 minutes apart. And that's a study design thing. But I would have understood what the T1 half-life is and said, okay, I'm going to space out 10, 15, 20 minutes even, so that way you minimize exposure of patients before you start seeing the side effects. Okay? But still, that was approved. And they had a reason why. I can't remember the reason why, but they felt that T1/2 was covered in that 2 minutes. But positive note, they paid out all the patients anyway. Even though they were found not guilty, the court did not require them to. It was like every patient got like some millions of pounds of dollars, so they're like set for the rest of their life, basically. That's a nice positive story that I will give you guys about conclusions. That's positive story number 1, okay? Positive story number 1, okay? To controversially to all the other negative stories that you see in all the movies that are made, like The Constant Gardener and all that stuff that we see, okay? But that's a positive story. All right. So we do that 1 to 2 years. Remember, we're at 7 to 8 years now. We get approval. We answer all the safety questions. We move on to phase 2. Okay? Phase 2 now, remember, phase 1, I had a super healthy heart because usually it's in normal healthy subjects. Why is that? Because I don't want a geriatric patient or a patient that has a constant cough or patients that have constant headaches, because then is that side effect, is that headache due to my drug, or is it because you constantly have headaches? I want to eliminate all these confounding variables. Okay? It's easy for me to see side effects that way. But then in phase 2, I need to know if the drug works now, because I've answered the safety questions. Now I need to know I can add efficacy. Does it work? And to prove that, I need patients that have that disease. That's why this heart is a little mopey and a little weak now. Okay? So typically these studies are 1 to 3 months long, maybe 100 to 500 patients. Again, 1 to 2 years, because I'm not going to, typically I'll do 6 phase 1 studies maybe to get out of phase 1, but I'll probably only do like 1 or 2 phase 2 studies. But the studies are a little bit longer. That's why it still evens out here. Okay? I will figure out the best safety and efficacy profile. I will also figure out the best dose, because by this time, remember, we did the dose escalation studies. I should figure out what is that best dose. I should also define the method of delivery. Is it oral? Is it a tablet? Even if it's oral, is it a crushed tablet that's pounded together? Is it a gel-filled capsule? Like, what's the best method of delivery? Is it an injectable? Is it a nasal spray? And what's the best dosing interval? Once a day, twice a day, 3 times a day? What is it? Okay? I should also anticipate and manage all of the AEs. When I say AEs, that's adverse events, that's side effects. Okay? But the clinical research term is AEs, adverse events. Any early recognition of toxicity. Why is that? Because sometimes you dose once and you think it's safe. But the thing is, there's a little bit left in your body that doesn't get rid of it for like weeks later or months later. And you dose, now if you dose every day, that little bit adds a little bit, adds a little bit, all of a sudden there's an accumulation effect. And that's something I would have never seen in a phase 1 study because you didn't dose long enough. But if you're dosing for a month or 3 months, I might see something. Okay? Many trials here are discontinued due to lack of efficacy, LOE. In other words, it's safe, but it doesn't help the disease enough to go out there and compete with the other gold standards that are out there. Now, if there's nothing approved out there in the world, okay, well then we'll probably move forward. But if there's other things out there already, like acne drugs and glaucoma drugs, and it's like, subpar, we're probably not going to move forward with it. And this is where I said, remember, for every 5 that make it into humans, remember 5,000 identified, only 5 make it into humans, and out of those 5, only 1 gets approved. Most of them get discontinued here. Yes, sir?
Is it at this stage, is this the first stage where you're actually only testing the drug for a particular use, or like in stage 1 where you...
No, so even in stage 1, although we're talking about healthy subjects, you should have already known what the indication is for. You can't just say, I want to take healthy subjects and give them this drug. I just want to prove that it's safe. I have no idea what I want to use it for. You should have, when you wrote the protocol, because remember, your observations, you should say, I think this drug works this way, based on the chemical properties of the drug, based on previous peer-reviewed published articles, and I think it will work for these type of patients. Even though you're not testing it in those disease patients, you should have that hypothesis already.
And if you've already used the drug, you usually don't. If you already used that drug before, is phase 1 really short?
Yeah, like Botox. If you're using Botox for a different condition now,
Hey.
but the safety profile is already established.
So if you have to make that argument. So if I sat here and just said, we've done previous studies, so I want to go get another thing in Botox. Can I skip phase 1? FDA would probably like, give me your scientific rationale. Now, if you could paint a picture and you tell me that Botox is approved, because by the way, I'm jumping ahead, but you know Botox, well, let's say fine lines, okay? You know Botox is only approved for the lines right here, right? The globular lines. Okay, it's only approved, officially approved for right here. But where do celebrities use it for? Here, crow's feet, smile lines, anywhere else you can use it, right? Basically, wherever why? Because the mechanism of action is exactly the same. Okay, and I'll go over the mechanism of action when I get to those slides. But that's what, so it's the same, so we know it's going to work, right? So when we decide, and we've already decided, we're doing the studies now, so let's say do crow's feet. Yes, we can make the argument that, but we'd have to show scientifically that, well, the muscle reacts the same here as it does here. If we inject it like this, and we're using the same concentration and the same this and that, it should react the same. So can we skip phase 1 and go into phase 2? If we paint that picture, and mind you, I just said it like in 2 sentences, it's like a 100,000 page thing, okay? The FDA will say, okay, we understand your argument. Sure, we'll agree. And they might say, well, do at least one phase 1. They might. But sometimes they will allow, and it depends on how strong your argument is. So I've been able to successfully skip I've actually been able to successfully skip phase 1 and 2 and go straight to phase 3. But you have to have a really strong and scientifically sound argument. And the safety profile needs to be there. Because if you cannot answer the safety questions either, you have to, So in other words, sometimes I had to do a phase 1 study, but then skip phase 2 and go to phase 3. Because I had to still answer a quick safety question, and then I jumped into phase 3. So it just depends on what your argument is, as long as you can paint a picture and connect the dots for the FDA. Okay? So now we go to what's the primary focus of phase 2. So we did all of this. We talked about all this, right? Yeah. Okay. So we finished that. So now remember, we added 1 to 2 more years. So we were at 7 to 8 years. So that is 8 to 10 years. Okay. So now, what is the key difference between phase 3? Long-term efficacy. What is the definition of long-term? It could be 6 months or it could be 12 months. So I've done 5-year-long studies. So it just depends. But typically, 12 months is the gold standard for the FDA that they want to see is long-term. Okay. But like I said, I've done anywhere between 6 to 5 years. It could be 700 patients, 1,000 patients, 5,000 patients even. This typically takes 3.5 years, okay? So what were we at? We were at, I said 8 to 10 years, and so you add on average this. So that's how if you add this to the 8 to 10 years, you're like at 11.5 to 14.5 years, right? Or 13.5 years. And this is where we get the 12 to 15 years, because the range actually is much longer. But on average, let's say it's 3 to 5 years. That's how we get to 12 to 15 years and $1 billion, okay? Now in this study right here, a couple of things to point out. We're gonna confirm all the safety and efficacy profile that we saw in phase 2, okay? So in other words, we should now be able to predict, we're going to see these side effects, and this is going to happen exactly, and we know that you're going to see this amount of improvement, mean change from baseline or whatever it is, and you're going to scientifically write that out. And you should know, and you have to hit that. And you have to hit that with a p-value of 0.05. That means 95% chance the change was due to your drug, 5% chance it was due to random error. Okay? And if you want to be above and beyond, a p-value of 0.01 is 99% chance versus 1% chance error. Okay? You will also do 2 pivotal trials. You'll do this one large phase 3 study. You submit it to the FDA, and they'll be like, awesome. Is it reproducible? Can you do it exactly the same again? So we already know they're going to ask that. So what we do is 2 sister studies, exact same study design, exact same protocol, but just different patients, different doctors, and we run at the same time because we already know they're going to ask for it. Okay? So we do it concurrently, so that way you don't waste time. Yes?
So what are your most successful strategies to getting the patients or with the trial?
What are the most successful strategies of getting the patients? Mm-hmm. What would make you want to participate in the study? Right? Let's be real. Okay? But I mean, obviously I could paint a lovely picture and say, no, you want to improve the quality of lives of other people. Maybe somebody in your family was diagnosed with that, and now you want to champion those cases do happen, but we also pay. I mean, right? If you see ads out here, participate in a psychological study, $15 an hour to answer some questions, you're like, dude, $15, let's do it, right? Right? Let's be real, right? So, I mean, we pay, but of course, there are rules. The IRB will review that. And for example, there's all kinds of rules like, the font of the money that you pay cannot be that much larger than the font of the rest of the thing. You can't be like, hey, participate in clinical research, $1,000, this big. No, you can't do that. There's a certain percentage, there's all these rules. You can't have it misleading. You can't, if there's 5 visits, it can't be like, I'll pay you $10, $10, $10, $100. It has to be a certain equivalent thing because that coaxes you to stay all the way through the end more. So it has to be more evenly distributed. And there could be a little bit of variation, but it has to be commensurate to what activities you do on each visit and things like that, right? But there are also just some people that just want to improve the research in that disease, so they'll participate in it. But we do pay people for their time. There are some countries that do not allow you, like the UK, you cannot pay a patient for their time. So it's truly like if they want to champion that disease. We are allowed to reimburse for like their taxi ride, but we cannot pay them for their time. Whereas in the US, we can say, we will pay you $25 a visit if you come in and do this thing,
The doctors that help you recruit patients and you pay them, do they have other responsibilities? So once they say, okay, I've recruited
Yes, the doctors not only recruit the patients, but they will see the patients and do all the procedures in the protocol. So the typical protocol, like if let's say a glaucoma study, a patient comes in, I'm going to want them to do a physical exam, a visual acuity test, an IOP test, a biomicroscopy exam, a fundus exam, do all these things. Oh, also check the overall just do a physical exam and just make sure that patient's okay. You also need to ask them how are they feeling. It's a non-leading question, because if they say, man, I just don't feel good today, I think I have a headache, guess what? It's a side effect. Right? But you can't say, do you have any headaches today? Because that's too leading. And plus, I don't want them to say it, because usually people are like, well, yeah, I think so. No, you say non-leading. How are you feeling today? Right? My stomach kind of hurts. I didn't eat today. Well, okay, that's a side effect, you know. But you could also say it's a side effect, but I don't think it's related to the drug, because they didn't eat today. That's why their stomach hurts. But all of that stuff is collected, you know. So yes, we collect tons and tons of data. You're going to collect your weight, your height, your blood pulse, your race, all kinds of different things, you know, because we want to slice and splice this data every which way. Because in the end, we're going to analyze it as all data. How about males versus females? How about Hispanics versus Africans versus whites? How about 20 to 29-year-olds versus 30 to 39-year-olds, etc. Every which way, we're going to slice and splice it, okay? And that comes in with the design. That's the 6 months I spent designing it, not only designing the protocol, but also designing how I'm going to analyze it, because we have to submit all that stuff to the FDA as well, okay? And at phase 3, the FDA can audit at any time, but guarantee you, since the phase 3 is what we're submitting for approval, they will audit a sample of your sites. Guarantee here, but they can come in at any time, okay? And there's actually an FDA office right here in Irvine, off of Jamboree. You first.
I was just wondering, the clinical study sites, does Allergan pay the PIs or the PIs pay to participate?
No. We pay the doctors, and that's why it's very lucrative for the doctors to participate. Remember I was saying a typical patient is valued at about $8,000 to $10,000 per patient. That money is going to the PI. Now, obviously, that covers, you know, using the instruments and paying for materials and lights or whatever, but on average, that's about what we would pay them per patient for the length of the study. Now, the study, let's say it's a phase 3 study, it's 12 months long. In a 12-month-long study, the total payout would be about $10,000. Let's just say to use even number. But that also includes, like, if they decided to pay the patient $100 per visit, trust me, they're going to bill us for that $100. So we're going to pay the PI this amount of money, but that also includes the $100 that we give the patient, but also everything else that we're paying them. And we're going to agree on a contract, because we might say, you know, hey, here's what we would pay, but they might come back and say, no, this is Irvine. It costs a lot more to have a business here than, say, Timbuktu, Tennessee, right? So they're going to, obviously, we're going to pay a lot more. And for example, that's why I said U.S. I'm going to use U.S. as a general basis, because the dollar is much more stronger than, let's say, in Canada. We would pay for the same exact procedures, same exact patients. It's much cheaper to run a study in Canada, you know, much cheaper to do it in India, okay? So we would pay them, okay? Somebody back there had a question.
So when a patient has side effects, do you conduct further studies to see whether it's a rare outcome or a rare side effect, or is it just something else that's related with a compounding factor?
So it depends on if the side effect is related to the drug or not, okay? So our job is to make sure that we capture all side effects, okay, all of them. And that's part of animal studies, to anticipate what the side effects are. So then you design to look out for them in human studies. But there might be something that did not show up in animal studies that shows up in humans, okay? So the first question you want to ask is the most important question is it related to your drug or not? Because if it's not, if the doctors, and we have doctors, and then also the doctor that's seeing the patient, if we've deemed that it's not related to the drug and it was something else, well, then we're done. But if it's deemed that it is related to the drug, then yeah, we need to alert all other doctors, and we need to probably do a little bit more research about that and what's going on, right? That's the first question. The second question is it expected or unexpected? So in other words, what if it's related to the drug, but we know that it's going to happen? So for example, there's a glaucoma drug called Lumigan. You put it in your eye, and it works for glaucoma. It lowers the IOP, but it also causes redness and hyperemia. You know, like when you wake up, like after a late night of studying, and you just naturally have redness, your eyes look like that. Well, that is a known side effect, but it's also related. So although it's related, it's known, it's documented on the warning, it's in the investigator brochure, so we're actually not too worried about that because it's expected. So the key is it related or not, and is it unexpected? That's bad. And then the third thing is it serious? And there is a global definition in the clinical research industry of what is the difference between a regular side effect versus a serious side effect, okay? And a serious one is like, it caused death, because obviously that's pretty serious. It's life-threatening. It caused a congenital anomaly, like if you had a baby and it caused a congenital anomaly. You were hospitalized due to it, or you were incapacitated, you were unable to move, or you can't, do something for that. Those 5 reasons is what is a definition of a serious side effect. That is a global, anywhere in the world, that is the definition for clinical research.
How do doctors and the researchers determine whether it's related?
Based on the patient's medical history, other drugs that they're taking, also just knowledge of the drug and the patient, the body systems, and also, part of it is also like if they honestly feel that is related and they're not sure, they can just check mark because they think it's related. Because the question is, do you think there's a reasonable possibility that's related? And so they'll answer that question. So, I mean, again, they can't answer it exactly for sure, but if they say it's reasonably related, then we're going to have to do more research, or we're going to have to design another study. So, for example, somebody has hepatic impairment, and they're not clearing urine enough, and they're, because we'll do a urine analysis, and their ALTs are way too high, or their creatinine is just way too high. Okay, so something's funny. Well, they check mark. The doctor really feels that it's possibly drug related. And they've spoken to our doctors, and we've spoken to each other, and there's a clinical rationale as to why they think that this affects the liver, affects the urine analysis. Okay. Just because you pass one phase, phase 1 to phase 2, phase 3, does not mean that you cannot go back. You can at any time go back. So while running this study, I will design another phase 1 study that is specifically for hepatic impairment, and I will capture all the urine that you take. So in other words, what I've done is I've created a radio-labeled study where I radio-label the drug. So right when you take the drug, it's radio-labeled in your body. I will collect all your feces, your urine, and saliva, and anything else that you spit out, like if you vomit. And you have to collect 90% of it, or else that is not deemed a patient you can analyze. So I have to collect at least 90%, okay? Then I will analyze that, and I will see where the drug went. And did the drug actually go through and pass through the liver and whatever it is that we're theorizing? That's one way I could do it. There's a bunch of different ways, so it depends on what that side effect is. So we would design a study. So remember, I told you, phase 1 is you have to answer all the safety questions. So if a safety question comes up in phase 3, I probably needed to redesign another phase 1 or phase 2. I would choose to do a phase 1 and answer that question. Did this really cause it or not? And if it did, then we have to put it on the label. Because just because it causes a side effect does not mean it kills a project. You have to, what if it's a side effect that cures HIV? Guess what? I'm still going to probably get that approved because HIV is death, and this side effect it sucks, but it's better than imminent death. If it's this liver impairment for acne, probably going to kill the project, right? Okay, so it just depends. Was there another question back there? Okay. So you finish all this stuff right here. You then do an NDA. That's a new drug application, okay? This is even more, hundreds of thousands of pages, okay? Now, I only put this on here. BLA is a biological licensing application. It serves the same purpose as an NDA, but it's just for a biologic. What is a biologic? Botox is. A biologic is when you use like an animal or a biological thing, and it's not a pharmaceutical chemical synthesized thing. So the previous Botox, we actually used we spliced the genetic genome of a rat, and it helped produce a certain component of our Botox. So therefore, it's a biologic, okay? But it serves the same purpose, it's just a different name. It's all the scientific data on the compound. Hundreds of thousands of pages. And luckily, since 2005, we moved towards the electronic clinical document instead of shipping boxes and boxes of all this paperwork. Priority review is 6 months. What is that for? Life-threatening, Lou Gehrig's, HIV, cancer kind of stuff. Standard review is 10 months. Average approval is 18 months. And how is that possible? Because typically, let's say it's a Me Too drug, another acne drug. You get 10 months of review. They'll come back with questions because they always do. You're going to have to answer all those questions. It's going to take like 2 months to review, to answer it. So you submit it 2 months later. So 10 plus 2 is 12. And then you say, listen, these are just a couple of questions. Can you please give us expedited review? And they'll say, OK. So then they'll say 6 months. So 10 plus 2 plus 6 is average is 18. That's on average. But like one of our drugs, we got approved in 11 months. So it just depends. Okay? Just so you know, there's also a Prescription Drug User Fee Act. It's called PDUFA. Sometimes you will read in the newspaper, such and such pharmaceutical company paid the FDA to approve their drug. And it sounds kind of shady, right? Like, how can you pay the FDA to approve your drug? Okay, that's so misleading. Everybody, when they submit the NDA, for a new drug, okay, we're not talking about stuff like at GNC, like health stuff or workout stuff or whatever, okay? We're talking about real pharmaceutical drug. When you submit the NDA or BLA, you must pay, right now, the current price is $1.54 million with that application. That's the application fee. That pays the fees of the doctors at the FDA to review the hundreds and thousands of documents, the 10 to 18 months of them sitting there reviewing it. That's what makes the FDA go round. I mean, there's some government funding as well, but we pay, right now, in 2013, the price is $1.54 million. Okay? That is, so that's not counting generics, manufacturing changes, CMC, supplements, and stuff from GNC workouts. I'm not talking about any of that stuff, okay? Because that's cheaper. So what do we do while we're waiting this 18 months? Yes?
You have to pay it no matter if you're approved or not?
Yes, that's the application fee. You might not pass, okay? So what do we do while we're waiting for approval? We do what is called phase 3B. I can't call it phase 4 because we're not moving on to phase 4 yet because we're waiting for approval, right? So we call it phase 3B. So what that is we're going to be a little bit more relaxed. Now remember, I said we want to eliminate as many confounding variables as possible, right? So we will design that study accordingly. And you'd be surprised at the number of things that people don't think about when they're designing a study. Because it's not like there's this cookie cutter thing that I say, oh, well, this is what we do. Here we go. There are so many different things you have to think about because every drug reacts differently. Every patient population is different. And if you want ocular hypertensive patients versus glaucoma patients versus serious glaucoma patients, it's different, okay? But then, and so we also we don't want patients that have these weird systemic diseases. We also don't want patients that are on all these other medications. So you can't be on this, you can't do this, you can't eat. I designed a study one time that because I knew that the drug was processed by your cytochrome P450s, which is what excretes all of the different toxins in your body. That if you drink caffeine, it will excite your cytochrome P450s, and you will excrete the drug faster. So that study, they were not allowed to drink coffee or soda or eat anything chocolate. And I had to have a list of chocolate chip cookies were not okay, brown. I had to have this list. For example, because I said no caffeine. For example, Barg's root beer, Dr. Pepper. I had to list all these things because people would always come back. Well, what about this? I'm like, come on, this is for example. If it has caffeine, but it's annoying. You have to come up with all these different things. And then you're like, well, what if they snuck it? And that was a question that we got from the FDA. So then we had to house them at a facility where they slept there, ate 3 meals plus 2 snacks. They bathed there. They had beds there. It was like a dormitory, but like prison, but like dormitory. We didn't call it prison. No one it's a nice dormitory. We have internet. We have video games, books. You can't go anywhere, right? And they came in. We had to pay a little bit more, but they came in. They liked it, And that's how we controlled. And that's also how you collect all that one radio label study. You have to do one of those kinds too. So that's how you collect all the urine and feces and all that stuff. But this now we could be a little bit more relaxed. Okay, fine. They know that some patients know that the drug worked, but now they're like waiting 18 months for approval. But they're like, we know the drug works. Can we get access to it? So we might design a phase 3B study, and we say, listen, the doctor still will see you, but we're going to be a little bit relaxed on it. If you're taking other medications, that's on you. Okay, but it allows us to see any other drug-drug interactions. Okay, because there might be other side effects, and we still need to report all those. But it's much easier for us to determine whether it was due to our drug or not, because that's what we did in phase 3. We were very strict. You cannot be on this. You can't do this. You can't. Here, it's like okay, it's a little bit more relaxed. But by doing it a little bit more relaxed, it allows patients to receive life-saving products before it can be purchased. It also allows us to see any other drug-drug interactions or maybe other risks and benefits in other different populations. Because many times, for example, I will not allow patients, females with childbearing potential, because I just don't even want to take that risk. But sometimes females, even though they're nursing or maybe they're pregnant, they want that drug anyway for whatever reason. If they choose to take it, that's on them. I mean, they should be warned about their adverse events, and that's what signing informed consent is. But if I design a study, I won't even allow it. I don't even want to consider it, because I don't want that to pass on to the baby. This will typically take 1.5 to 2 years, which coincidentally is about the time that you're waiting for approval anyway. So it's cool because now they're on this study getting drug, and then while they're getting drug, it gets approved. Boom! They could quit this study at any time because they could get drug now and prescription. So either way, it's like a win-win. So it's kind of cool. Okay? Then what do we do after that? So it's approved. It's out on the market. You can get a prescription for it. Doctors can write prescriptions for it and whatnot, and you can get it from the pharmacy, right? Are we done? Are we done? No, you're a little skeptical, because if we were done, I would have no more slides, but I still got more, okay? We have phase 4. Remember, I said bucket 1, bucket 2, we get it approved, I'm done with it. It goes over here, sales and marketing. Sales and marketing are the people that figure out 4 out of 5 dentists choose Trident gum over whatever, or 4 out of 5 pediatricians. But also, I mean, I say that in jest. They also figure out other things too. They do a lot of other post-marketing studies. A lot of times we do head-to-head to prove that it works against the gold standard, but then they will do other ones to say like our drug is better than this other drug because of all these other cool things, you know, whatnot. A lot of times also, the FDA will say, hey, it looks like it's good, but can you please do a it's called a post-commitment study. We will approve it now with the agreement that you will do a 5-year long-term study. Now, you ask, why wouldn't the FDA require you to do that before? Because the patent would run out, and they recognize that. So they say, okay, we'll approve it now, but you have to do this post-marketing commitment study, right? That is why, unless you know somebody like me that works at Allergan, sometimes when a drug newly gets approved, you definitely want to consult a doctor. Because we might know long-term effects, but long-term, I just told you guys, was 6 months, 12 months. Typically, you could assume it's 12 months. The 12 months is it's like 90% of them are 12 months. But it might not be 5 years, okay? And something, for example, as simple as ibuprofen, if you take that 2,600 milligrams every day for 5 years, you will have really bad side effects. You will actually probably become immune to it, and the inflammation process is going to be all wacky on you. Or if you take, 3,000 milligrams of aspirin every day, you're going to rub your stomach raw. If you do that every day for like 6 months, right? But nobody takes that much aspirin, but chronic athletes, other than chronic athletes, but we would not have seen that in a clinical study. So that, I'm just cautioning you guys. That's why sometimes a drug gets approved, and then a couple years later it gets recalled, because we did not know what the 3-year, 5-year results were. But how did we find out? Because there was probably a post-commitment that we had to say, okay, if we agree to do this study if you approve it now. It also, again, allows us to examine other risks and benefits, other long-term safety stuff, broadens our patient population. It allows us to also broaden our label. Because the thing is, the label has to reflect the patient population. So if we said adults 18 to 65 years of age, then the label will say, this is prescribed for adults 18 to 65. What if you're 66? I can't say that technically. If the protocol was written that way, if there was an upper age limit, then I have to put an upper age limit on the label. But if I do a phase 4 study and I say unlimited age, then I could change, and it's successful, then I could change the label. I could broaden it a little bit. And if I only did for this one indication of glaucoma, I could only say it's for glaucoma. I could only advertise it's for glaucoma. But if then later on I do a study for ocular hypertension, which is the stage right before glaucoma, then I can say for ocular hypertensive or glaucoma patients, right? For dry eye patients, for this, for that. So that's why you do these post-marketing studies, okay? Now here's another story about pharmaceuticals, okay? I don't know if it's gonna be good or bad, right? It's like a cliffhanger. Is it going to be good? Is it going to be bad? I don't know, right? Okay, Vioxx. Vioxx in 1999 was it was approved by Merck. It was for arthritis and chronic and acute pain. It was approved in 1999, and it sold $2.5 billion a year. And back in 1999, that's a lot of money. I mean, $2.5 billion is a lot, but back then, that's a lot, okay? They agreed to do a post-marketing study, a 5-year study. In 2004, after long-term safety studies, they recognized that without the drug, your risk of heart attack was 0.1%. That's without drug, okay? With the drug, after 5 years, your risk of heart attack was 0.4%. So it's still less than 0.5%, right? Okay? But 0.4 is 4 times more than 0.1. So it increases your chance of heart attack 4 times. So when you say it that way, that sounds like a lot. But if you think of it as it's 0.4%, that's less than 0.5%. Honestly, for me personally, I would think it might be worth it if I'm in chronic pain like that. But I'm just saying, just pointing out, you could look at it that way, or you could look at it as it increases 4 times the chance. So when people hear that, they're like, how did this thing even get approved? And then for stroke, there was 0.78 events for every 100 patient years that a patient would take the drug. If a patient took a drug for 100 years, you would have less than 1 event, okay, 0.78. After 5 years, there was 1.92 events. Oh, I'm sorry, no, 1.5 events. 1.5 to 0.78, that's about twice. okay? But it's still, over 100 years, there's about 2 events of stroke. So based on that, and the FDA did not make them do this, Vioxx went ahead on their own and took the drug off the market. They said there's other pain relievers out there. Take your Advil, take your ibuprofen, take your Celebrex, take whatever else. You are not going to get Vioxx. They took it out without being told. They were not mandated. Okay, I think that is huge because they basically said no to $2.5 billion a year every year. And the funny thing is, they could have been slapped on the wrist and said, well, not that they were slapped because they just didn't know. The FDA came back and they actually said, we actually like this drug. Why don't you put it back on the market, but just add on a warning on the label saying it can increase your chances of da-da-da-da-da and consult a doctor. The FDA in 2005, May 2005, voted in favor of putting it back on the market as long as they amended their label. And the company said, thanks, but no thank you. There are other products out there that are safer, so use those ones. Health Canada wanted it so bad that in July, 2 months later, July 2005, they voted 12-1 in favor of putting it back on the market because the Canadians wanted it so bad. And again, they said thank you, but no thank you. I think that's huge that a company would say no to $2.5 billion. I think that's really huge. Okay? That was a positive story, by the way, if you guys didn't get the gist. Yeah.
But maybe this is the dark side. I can imagine a company saying no if they're really worried about lawsuits.
Yeah, that's possible. That's true. That's true. And I can see that too.
Juries award so much money.
I have a mouse in my pocket. What's going on here? This one was weighing me down. What do I have in here? Yes.
So just to be clear, in order to get approval, all you have to do is prove that this new medication is as good, as effective as the current treatment out there, or do you have to prove that it's better than the current standard treatment?
There are different routes that you can get approval for. Okay, but you have to technically, if I want to do the lowest case denominator, you have to prove that it's not inferior to what is the gold standard out there. That is the biostatistics term, so it's called a non-inferiority study. You can show superiority, okay, but from a clinical study design perspective, let's just say I designed a study saying that it's superior, okay? My drug is superior than yours, and it will show by a 5% margin, let's just say. What if I only beat you by 4%? Guess what? It's not superior. Due to the definition that we agreed to with the FDA, I cannot get approval on that. So would you then go out for a superiority design or a non-inferiority? Right? I would probably strategically design it as a non-inferiority, but still kill it by 4%, and then advertise being like, man, we killed you guys by 4%, right? So technically, as long as you are, and sometimes you might make an argument. Again, it's a picture, it's the story that you want to paint to the FDA. What if you make an argument saying, for example, glaucoma, if you decrease the IOP, the pressure in the eye, it's called IOP, intraocular pressure, and it's measured in millimeters of mercury. An average patient is 10 to 18. Okay? And once you get above that, it's considered ocular hypertensive. And once you get past like 25, 26, you're considered glaucoma range. Okay? Every 1 millimeter of mercury that you decrease the chances of blindness by 10%. So it's valuable. The FDA feels that 1 millimeter of mercury is very valuable. Okay? So then you could design your study to say that this drug will decrease your IOP by 1 millimeter of mercury. Is that as good as some of the other drugs out there? No. So you don't have to be as good as that. In that particular case, because the FDA has already predetermined that every millimeter of mercury is significantly valuable, you can get it approved on that. So it just depends on what is out there already. So you can't just say, well, this is for this is for that. It depends, right? So for HIV, there's nothing out there right now. I mean, there's some things, but nothing actually cures HIV. So if you've got something like that, there is no gold standard. So you're golden, right? Yes.
I have a question about patents and so I was wondering if when Vioxx patent runs out, if the company wanted to just copy the drug, how would they go about doing that?
Okay, so I will table your question because I have slides on that, and hopefully I'll be able to answer it. But if it doesn't, bring it up again because I have a couple of different examples of things that you can do. Okay. All right. Let's see. So we did all this. This is about 2 years. Okay. Any questions on post-marketing phase 4 studies? No, because we're going to get into some really interesting stuff right now. Okay. If you thought that was interesting, man, we're going to get into some really fun stuff now. Okay. By the way, this I designed and created, and I could send you this if you want to. This summarizes everything that we just talked about. I have up here a little note of the 5,000 compounds, 5 making the humans. Of the 5, only 1 make it. And I have the 5,005 one there, 15 years about. The chemical synthesis, animal testing, I said all the toxicity, carcinogenicity, toxicology, about 6 years. You file the IND, you wait 30 days for the first in man, you do your phase 1, main priority is safety, you do your phase 2, you can add efficacy, you do your phase 3 long term, submit the NDA, this takes about a year and a half. While you're doing that, you can do phase 3B, you get approval. Phase 4, post-marketing, about 15 years, $1 billion. That's a reference of 2006, so it's actually probably more now. And a summary of all the different phases, and you might not be able to read this because of but when you have it on a computer, you can read that. But all of this right here just summarizes everything that we just talked about. Okay, just so you know, in a nutshell. Okay, but wait, there's more. Okay. I'm selling you guys stuff. So what about generics, right? Because now we're going to talk about generics and patents and things like that, all right? Why do generics come out there, and why do we need to reformulate and do things like that? Because we need to protect and extend our patents, okay? Now, just so you know, people always talk about patent extensions. It's actually a lot more difficult than people think. There's only really 2 ways to extend a patent. What people really talk about is market exclusivity, but they always interchange those incorrectly, okay? And other ways that we could protect our market share is getting approval for different indications, okay? Or what we could also do is take advantage of a shorter FDA approval. So in other words, if you were able to, instead of doing 12 to 15 years, scrunch that down, you get so many more years after, right? Make sense? Okay? And this is why it's so important. Generics, typically, when they come on the market, capture 57.6%, so about 60% of the market immediately. And then it gets more when people get more comfortable with generics, right? Okay? Because, for example, if I ask you, do you want prescription strength or generic? What do you think is better? Most people think prescription strength is better because it's prescription strength, right? That's a marketing thing, okay? And it will increase over time. The bigger you are, also, the harder you fall. These are 3 examples of drugs. The year was set to expire. The sales before it expired, the sales after it expired. They lost 83 to 88% almost on the first year. Because for generic companies will target these and then really sell, and market and advertise on that to really try to take more of the market. So you're thinking, okay, well, why don't everyone just go after generics, or why can't we just combat them, and why are generics so much more lucrative? Why can generics sell for so much less than pharmaceutical companies? You guys are holding out on us because generics can come sell it cheap, but why can't you sell it that cheap? You know why? Because we spent 12 to 15 years and $1 billion. Let's see how much generics spend on that. This is everything that we just said that we did. Chemistry, manufacturing, controls, labeling, testing, animal studies, clinical studies, and bioavailability. All of this right here. There's 12 to 15 years. And what is bioavailability? To show that it's available in the blood. Remember, I told you we did those PK blood draws and whatnot and build that curve. Okay. This is what generics have to do. Okay. All right. Chemistry, manufacturing, controls, labeling, testing. Okay. And bioequivalence. What is bioequivalence? They have to use the same active ingredient, the same route of administration. If it's an oral pill, it's an oral pill. Same dosage form, same strength, same condition. So everything that's intuitive, right? It has to be the same, obviously, right? They have to figure out what the absorption, distribution, metabolism, and excretion is, which is what we did already also. And they have to compare it to our brand name drug. You can do this in 6 months. Wait, let me say that again. 12 to 15 years, 6 months. And they can start this at any time. So when they know that the patent's going to expire here, they can start these studies right here. So that way, the day that it's ready, they will also have a marketing campaign ready, print things ready, ads ready to go. Boom, release it that day. They can do that. That is why generics, because obviously 6 months is going to cost way less than 12 to 15 years. And we're pioneering and trying to figure things out. And then once we've figured it out and published it, they know the blueprint. Oh, that's what you guys did? Cool. We're going to do this, and we're going to do it in 6 months. Right? That's why generics are so much cheaper. It's not because we are being weird and stingy about it. It's because we have to make that $1 billion back, but the generics do not. Okay? So some people don't understand that. All right. Let me go over a couple of other cool things. Oh yeah, one other thing I want to mention out to you guys. You know how I talked about what if you were Superman and you were able to get a drug approved in less than 12 to 15 years? Let's say you're Superman and you get approved in 5 years. Okay, for whatever reason, you're just awesome. Okay, So then you're thinking, well, I have 15 years left on my patent, right? Okay, there's another law that says the consumers, the public, should be able to get access to a drug after a certain number of years, generics that is, and at a certain price. So that law says that you can only be protected by a patent for no more than 14 years. So therefore, although a patent is 20 years, because typically it takes 12 to 15 years to get approved, if you're a Superman and you only took 5 years, you do not get the other 15 years, you get 14 years. So after 19 years, generics can come out, okay? Because there's a certain checks and balances. They understand that the pharmaceutical company needs to make their money back, but they also feel that generics and a cheaper alternative should come out after a certain number of years, okay? So let me talk about a couple of these things here so we can try to address your question about patents and things like that, okay? Market share. Sometimes you want to go out there and try to get more of your market share by getting new indications approved. Because really, that's not extending a patent. That's just getting approval for a different indication. When you get approval for a new indication, you get market exclusivity. That means only you can market for that use. That, when I say indication, that use. A generic could come out, but they cannot market for that indication until a certain number of years passes. Botox is considered the penicillin of the 21st century because it's used for so many things. What it does is there's a receptor, and when your brain says, I want to flex something, it sends out, it sends out calcium. It goes into there and it flexes. And then when it wants to unflex, it sends out acetylcholine, right? Okay. This receptor that receives the calcium ion, the Botox cleaves it. Okay? So the muscle is still there. The brain still sends a signal, but now it's just floating around like, oh man, where's that receptor? I want to ring the doorbell, but I can't find anything. So it doesn't flex. Okay? So now when you understand that if it doesn't flex, where can you use that to your advantage? That's why the wrinkles go away. A wrinkle is your body knows that you're about to move that muscle, so it kind of halfway flexes. So when you go like this all the time, or you go like this, it kind of knows that you like to do that, so it kind of halfway is already there, and that's why you get those wrinkles in there. Okay? When you inject it in there, it relaxes it just like a newborn baby, and it's like smooth, right? Okay, and that's what it does. So you're thinking, okay, well, that's why if it works here, obviously the mechanism of action should work here, should work here, should work here. So we use that off-label use. But what else can it be used for? The original approval for Botox was for eye spasms, hemifacial spasms, and strabismus, which is cross-eyedness. So sometimes people have these little tics where the eye just spasms like that, because that's a muscle just keeps flexing. Well, you inject it wherever and it relaxes that, it doesn't allow that muscle to flex. Or when you have facial spasms like this, okay? Strabismus is when one of the muscles in the inside is stronger than the one on the outside. So if you inject it properly, it allows the eye to come back out straight, so you're not cross-eyed anymore. Patients that sometimes they have a hand that flaps, or it's stuck like this, right? Like certain mentally handicapped patients, it's because their bicep is overpowering their tricep. So if you inject this certain area, it will allow them to relax, and it'll stop them from flapping. It's called spasticity. Okay, so there's all kinds of different uses that you can use Botox for, and Botox is approved for 23 different indications in 83 countries, and that's the reason why it became a billion-dollar drug. But everybody knows it for the fine lines and wrinkles. There's glabellar lines. That's what it's known for. But strabismus is a cross-eyedness. Eye and facial spasms. Cervical dystonia is like when your neck all freezes up. Hyperhidrosis is underarm and palm sweating. It's now approved for overactive bladder, migraine, headache. There's just so many different things that it's approved for that it gets no credit for. Okay? But you every time, so if a generic were to come out, let's say, every time we get approval for a new indication, we get some type of market exclusivity, usually 3 years, that only we can market for it. Okay? And if the FDA or anyone catches any other company marketing for it, you can get sued and you will pay millions and millions of dollars. Yes?
Sorry, can you see how long if you found a new way?
3 years.
3 years.
Yep. Sometimes we find indications based on accident. And I hope this partially answers your question. Okay, I know you were talking about patents and what do we do. So that was one way to extend the market exclusivity is getting approval for a new indication. Here's another thing that we can do. Okay, just so you guys know, you guys have heard of Latisse. It makes your eyelashes grow longer, thicker, and darker. Okay, and it's pretty awesome, right? You notice longer, thicker, darker. See that? We were trained on that movement. Okay. Okay, how did this happen? We have a drug. It's called Lumigan. The drug name is Bimatopros. Okay, you put it in your eye, and just like any eye drop, you blink and it gets around, right? And this is just to exhibit this. Okay, we use the colored water, and when you blink, it gets around the eye all over. Okay, and it naturally touches these hair follicles. 60 to 85% of the patients complained about a side effect. Male or female, didn't matter. They complained that their eyelashes would get longer, thicker, darker. And hence why our label is longer, thicker, and darker. Okay? And why only 85%? Because some girls they didn't want to complain about it. They were like, this is kind of cool. I like this. This is not what you're talking about. Because when you think of side effects, you think negative. Technically, a side effect is any untoward, not normal event. But some girls were like, well, I don't want to complain about it because they might take away the drug, Okay? So then we saw that we got there. But we don't want to give that drug to patients that don't have IOP pressure problems, right? Because it lowers the pressure. Because if it's too high, it's bad. But if it's too low, it's bad. So how do we apply this to the hair follicle without putting it in the eye? Also, this is the drug that I told you, it causes the white part of your eye to have that redness. We don't want that either because that doesn't look pretty, right? Because if you're getting pretty lashes, you don't want people looking at your eye and be like, damn, you look like you got pink eye. What's going on here, right? So we're like, okay, well, what if we created a applicator tip? And we put a drop on that. And then we apply it just to the upper eyelid range on the skin, not in the eye. But it still touches the hair follicles, okay? Then when you naturally blink, the two hair follicles touch each other, but it still doesn't get in the eye. So then now the hair gets the drug without getting in the eye. No redness, no IOP lowering, but hair gets longer, thicker, and darker. This is a patient at baseline. 4 months later, this is the patient. And look how much longer it is. This is a real patient that we took pictures of, and I have hundreds of examples of this. You could see that honestly after 4 months, I think it's a little bit too long because some of these, back there you might not see, but up here, I think you should trim some of these because it's getting a little bit long right there. Like there's one that like sticks way out past everything else. Like, I don't know, you should like trim that right there. But I mean.
Tried it on bald spots.
Oh, sir, you trying to get me fired here? These are like top secret things here. I'm gonna put it this way. It excites the hair follicles and allows hair to grow anywhere you put it. Okay? So for them Asians that want to grow some facial hair, because we have trouble growing facial hair. Just kidding. But so yeah. I mean, like if you put it, here. Some women want thicker, but you probably, we're reformulating because you probably want something more foamy or like a muesli to put in the hair. Because if you put it in the hair like a drop and it goes drip, 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 and it goes down here, all of a sudden you get lines of hair like this, that's not pretty, right? That's not pretty. We don't want that, right? So, I mean, but we have to reformulate. But yes, in theory, it can work, and we are working on those studies, okay? And here's the thing. Remember I talked about p-values, 0.05, and then gold standard 0.01? This got approved in 11 months. Why? Because the p-value was 0.000001. So it was like, that's awesome. The FDA was like, no questions, approved. That was like, this is the first time I'd ever seen no questions. Like, really? No questions? Awesome, right? Approved. And to help with that, this patent was set to expire. The drug for bimatoprost, for Lumigan, for the glaucoma, approved in 1992, set to expire in 2012. Well, while we were doing these studies, in 2004, 2003, 2004 is when we were getting these reports of the longer, thicker, dark lashes. So we immediately said, we need to figure out a way to do this. And we patented the idea, not the drug, but the idea to create a proprietary tip to put a drop in here and use it this way. So not only can you patent a chemical, you could patent a method of use. You could also do a production method patent, like how the step, like in organic chemistry, the steps you got from A to Z. There's like, you could go 20 steps this way, or you can do 7 steps this way, or whatever, right? You could patent that production method too. But this one, we patented the method of use of putting a drop on an applicator tip and applying it here. If a generic comes out for this, cool. But if they advertise using it this way, we can sue them. So they cannot talk about it this way. But if you're smart, you get the generic, you put one drop in I usually recommend opening the cap and just put one drop in the cap. You buy a 99-cent paintbrush from the store, art store, and you go like that, and you're good to go. But I didn't say that. Oh, wait, you're recording this. Oh, man. Come on, man. I'm going to get fired now.
Are there any side effects for if you're using it and then you quit? For example, like what if you're using it and then if you quit, your eyelashes fell out or something?
Wow. If we had that side effect, we probably would have to report it, right? And we would probably mark treatment related. And no, but yes, if that happened, then we would have to report it. So probably the study design was built that patients are on drug for a certain amount, and then we follow them off drug for a certain amount to see what happens. And I will tell you, though, what happens since I actually worked on some of these studies. Okay, I think that, so this is just my personal, right? So everything I just told you was factual. Right, now I'm going to step out of the factual. The p-value is 0.000001 works. You see this, it grows, it works. Longer, thicker, darker, all that. Okay, I'm going to step out of that. I honestly believe that when you use fake lashes and things like that, your eyelash is meant to hold a certain weight. Okay, the fake eyelashes that I've seen that some people can't get, because my sister-in-law has these really long ones, like Dolly Parton size ones, like snuffleupagus kind, right? It's actually too heavy, and when you take it off, it actually, they don't tell you this, but it actually rips out the hair follicle from the hair follicle. So there's actually, after a certain months of using it, they will tell you, you have to not use it for X number of weeks, and new lashes have to grow. Why? Because they need new lashes to grow so they can glue these fake ones on, okay? The people don't always tell you that when you go to the salons, but that's actually what happens, okay? Your actual hair follicle cannot load that weight. What this does is it excites the natural growth cycle. So there's like there's a catagen, anagen, and telogen phase of all hair. What it does is it prolongates the natural growth cycle. It will only grow, though, as long as your eyelash can sustain that load. So it is the appropriate length and weight of what is normal, okay? And so then it can actually load that correctly. And so what happens is if you stop using it, all it will do is go back to your normal eyelash length. Because normally after like 45 days, your eyelashes naturally just fall out anyway. You know, they slowly kind of fall out. And what will happen is the longer one will just fall out, and then when the next one that grows back, it'll just grow back to whatever your normal length is. So it doesn't just fall out like that. You know what I mean? Also, the cool thing is if you use it every day and you get this length, all you have to do is after that, 1 to 2 times a week as a maintenance dose to maintain that. So that bottle will last you so much longer. After 4 months and you attain your dose that you want, you can just do once or twice a week and you will maintain that. And it's actually really cool. And it's so much healthier for you. Okay. Any other questions about eyelash growth? Because usually that's when the women perk up and want to ask all these questions. No, I'm just kidding. I'm just kidding. Okay. Also, you can't just say for eyelash growth. You have to come up with a medicinal diagnosis, okay? And when cancer patients lose their eyes because of all the radiation and chemo, it's called hypotrichosis, okay? But of course, it's, for pretty lashes, but I mean, right, but we have to have a medical term, all right? So you have to make it sound like a disease. Hypotrichosis, we're saving lives out here, all right? Making people look pretty. Okay, there's another thing that's most commonly used. It's called compassionate use. Compassionate use refers to the treatment of a seriously ill patient using a new unapproved drug when no other treatment is available. Okay? So a lot of times people are like, oh, can this patient just get some drug for compassionate use? No. It has to be there's nothing approved out there in the world. You're currently working on the studies, but let's say you're stuck at phase 1 or phase 2. It has promising results, so the FDA will say, you know what? It's promising. Continue doing your phase 2, phase 3, but we will allow doctors to prescribe this to patients that have that particular disease. In 2009, the FDA issued that decision for compassionate use for IPLEX for amyotrophic lateral sclerosis. That's called Lou Gehrig's disease, okay? What that is the myelin sheath in your neurons slowly deteriorates. So when your brain sends the electric impulse to, let's say, move some muscle, okay, and we're talking about voluntary or involuntary muscle, the myelin sheath, the insulation is slowly degrades, and the connection and the message does not get there. So guess what happens over time? When you lose that insulation, not only your voluntary movements, but your involuntary movements, your breathing, your heartbeat, your sphincters, that you slowly start to lose that, and that's a really painful way to die, right? Because you're thinking, I need to breathe, but I can't breathe because you just, like when you're in your sleep or whatever, no one ever sits here and thinks, oh, my heart needs to beat now, and beat now again. It just does it, right? Imagine that your brain can't send that signal anymore, So that actually got approved for compassionate use. It's a lot less common than people think. All right. Now this one is,
Sorry, so
yes, sir.
It was a drug that was already approved for
No.
No.
It was not approved for anything yet.
Not-
Yeah. Okay. So this is one of my, where did I go? Compassionate use. Okay. Reformulation. And by the way, another thing, you said, well, can we just extend the patent by reformulating or whatnot? You can't just reformulate it. You have to reformulate and add some kind of benefit. You either promote patient compliance, reduce the dosing or ease of use, or have better side effect profile. So in other words, when I say promote patient compliance, if you had to dose something 4 times a day, how many people do you think would actually be diligent to dose it 4 times a day for the next 6 months? Almost no one will. Everyone will miss one dose somewhere. Okay? But if you were to then maybe do it once a day, you're more likely to do it than 4 times a day. 6 times, anything more than 2, we all frown because we know patients are going to be non-compliant. If once a week, once a month is better, right? Okay? So any of these things. And when you reformulate, you can go from tablet to liquid-filled gel caps, cream to gel to oral, or an emulsion, which is oil-based, to aqueous, which is water-based, or anything like that. Or you can do stereoselectivity. Okay? I'm not even going to comment on that. I'm not going to bring any attention. I'm going to look over here and not draw any attention to it. All right. Stereoselectivity. This is the awesomest example that I want to give. Okay? Okay, you guys remember, do you guys all take organic chemistry? All right, so organic chemistry, right? You know enantiomers or stereoisomers, right? It's like mirror images of each other. Your hands are enantiomers of each other. They're the same, but they're different. Like they look the same. They're mirror images, but they're different, right? Because thumbs are on the opposite side, but it's the same, but different. Same, different. Okay, got it? Okay. So all chemicals, 3-dimensionally, are like that, right? All chemical structures, molecular structures. So typically when you create something, usually there's a racemic mixture of 50-50, right? So 50 rights, 50 lefts, okay? So the cool thing is, Prilosec is called omeprazole, and this is the chemical structure of it, you know, and this means like it's a wave versus pointing towards you or whatnot, okay? And it's a 50-50 mixture of R's and S's, okay? That's Prilosec, right? You guys have all seen Prilosec or Nexium, the purple pill, right? For acid reflux, for heartburn, things like that. Okay, so the patent was set to expire, and the company was like, well, what if we took all the S's? So let's just say all the right hands. We think that 100% of the right hands is better than a 50-50% mixture of the rights and lefts. I don't know about that, but so they said, well, we're going to try that, and they took all the S's, right? Because R and S just means right, left hand, and they ingeniously came up with a name. So to change the name from omeprazole to esomeprazole.
Oh my gosh.
Okay. Okay. And so they're like, whoa. And then they did a study. So now, and then just remember, we talked about patents taking like 60%, and I showed you examples of 80-something percent, 87.7%. Okay, and the bigger they are, the harder you fall. Prilosec sales in 2001, and the patent was set to expire at the end of 2001. 3.7 billion in the U.S. and 5.9 billion worldwide. This is more than any of the other examples that I gave you before, right? And the bigger they are, the harder they fall. So Nexium, they got approved by using this S-omeprazole thing, okay, in 2001. Prilosec, they also got approved over the counter in 2002. Now, what is the advantage of that? Because remember, I asked you before, what's better? Do you want generic or do you want prescription strength? Do you want over the counter or do you want prescription strength? Prescription strength just sounds stronger, right? It's just a marketing thing. You really have to know your drugs, okay? But the thing is, if Prilosec gets approved over the counter, then generics have to be over the counter as well. So now I can sit here and say, do you want prescription strength Nexium, or do you want this over-the-counter generic stuff? First of all, it's generic and it's over-the-counter. They even bash their own stuff. Do you want over-the-counter Prilosec, or do you want prescription strength Nexium? They can even bash their own product. So that way, if you don't want the Prilosec, you're definitely not going to want the generic, but you're going to buy this thing, which is exactly the same as Prilosec. It's just right hands versus right and left hands, right? People don't know that, okay? Perceived notion that prescription strength is better than over-the-counter. Guess what happened? In 2003, the Nexium sales alone was $3 billion. You're like, okay, well, a hair less. I couldn't find, but you have to also add in, they still sold some Prilosec. So what is that? So let's add Prilosec and Nexium together. $6 billion. They did not skip a beat. Not skip a beat. That's considered a success. You don't even need to sell anymore. $6 billion is a lot. But remember, I showed you examples of 60, 87% loss. They didn't lose anything. In fact, they actually gained 0.1 billion, right? This example of whoever came up with this idea, I think is marketing genius. Now, do I agree that rights are better than rights and lefts? Scientifically, no. But they proved it somehow statistically, and they got it approved. Whoever came up with this is actually used in the Harvard Business School MBA program as the ultimate example of what you could do for a marketing business thing. I think that's awesome. So whoever came up with this is like famous. Because I know a student that enrolled in the Harvard Business School, and they told me that this is actually the example that they use to discuss. I think that is phenomenally fantastic. And I guess the last thing I could talk about is orphan disease. So, because a lot of times I used to grow up thinking, man, it was so easy to discover stuff back in the day. Like, you know, Louis Pasteur just like boiled some stuff and then you found these things or whatever. Man, I can't do stuff like that now. right? But the thing is, people don't realize there are so many other diseases and drugs out there that you can discover, okay? Orphan status is a rare disease. The orphan term means that it's really rare, okay? In the US, we define that as less than 200,000 people is affected by this disease, okay? Or that there's no reasonable expectation that you could ever make your money back. Now, this is a little bit harder of a definition. This is more numerical. You can actually figure that out doing an epidemiology study. If you ever work on an orphan status disease drug, the benefits are you can get 7 years of, not only the patent, but you also get additional 7 years of market exclusivity. You can get tax credits of 50% back of anything that you spent on it. And remember that $1.5 million, $1.54 million, FDA will waive it. Because they know that the market is so small for that, you're not going to make your money back. So they're trying to like entice you by giving all these benefits. Same thing in Europe. The Europe actually, I think they have a better definition. They feel that since the population is constantly growing, which it is, they'll use a ratio. If for every 10,000 people it affects less than 5, it is free protocol assistance, which costs about $100,000. And they will reduce their filing fees by 50%. Okay? So pros and cons for both. But I think that's really awesome. Okay? And since there are over 6,000 other rare diseases, and since 1983, FDA has only approved 325. The Europe has only approved for 50. You add that together, that's 375. That's only 6% of all the rare diseases out there. So there's so many other things that we are out there to research. And in fact, I'm actually working on something right now. Restasis right now, if you guys are unaware, is the first and only therapeutic drug to increase tear production in patients with dry eye. It's the first and only out there. We own the market for that. This is our #1 topical ophthalmic seller. In North America alone, this outsells Botox. But just globally, Botox outsells this because Botox is approved in like 83 countries, and this is only approved in like a handful of countries, or 29 countries for one indication, whereas Botox, remember I said it's 83 countries, 20-something indications. But it outsells Botox. But it's not approved in big markets like Europe, Asia, India, Australia, okay? So the cool thing is I said, well, what else can we use this drug for? Because if I can get this approved for a different disease, I could then ship it to that country, and doctors can use it for whatever they want, right?
Sorry, it's not approved there because they have...
Spent 2007, 2008, and part of 2009 designing the study. I got it started in May 2009, okay? Now, I was told by the FDA I need 124 patients, and my company gave me 18 months. Why? Because back in 2001, the largest partnership between the UK and US, they ran a study for 18 months. They enrolled 22 patients, okay? And my company, my boss is saying I need 124 patients because it's a rare disease, that's why. So all those numbers that I told you before, throw that out the door because it doesn't apply to rare diseases. At Allergan, we tried to run a study, different people, not me, before my time, back in the day, in 2004. And after 7 months, they enrolled 10 patients. Maybe after double that, 14 months, maybe 20 patients, so they're about on track with this. The study was canceled. So in 2007, my boss said, "Can you see what you can do with this?" And I'm thinking, well, they were unsuccessful. What do you want me to do with it? He said, well, do it. I read over 300 articles on AKC and the standard of treatment, and I redesigned the study accordingly. I spoke to KOLs. I did all kinds of different things. So if you ever worked with me, I would teach you these things. If you were my intern, I would show you what I did. But if I tell you now, then all my secrets go out there, and then I would have to kill you. And I don't want to kill anybody today, okay? So these are my proprietary secrets, so that's what makes me valuable to the company. So I had to enroll 124 patients in 18 months. And mind you, this is what they enrolled last time. So what I did, using my secret techniques, I was actually able to enroll 124 in 13 months, and I blew the timeline by 5.5 months. That's huge. Because remember I told you about a $365 million a year drug, right? 5.5 months times $1 million a day for 5.5 months, that's a lot of money. But this is not just a regular drug. This is our #1 topical ophthalmic seller. So it's like $700–800 million a year, okay? So they said, keep going, see what you can do with it. At 1 more month, I enrolled 150. 1 more month, I enrolled 180. Now it gets to the point where I'm going way over budget. Because remember I told you each patient is worth $10,000 or whatever? So they were like, hey, they actually told me you need to stop. And I'm all, are you sure? I can go more. I can get more. Now I'm all getting all cocky. I get more. Which time? But before I was like, are you sure you want me 124? Now I'm like, oh, I get more. You want me to stop? Okay, I'm going to stop because you told me to. All right? But this is the largest study in AKC in the world. And this is also what I used to get that questionnaire that I talked to you about earlier. These are the things, and I'm saying this to inspire you guys to let you guys know there are diseases out there you can work on that have been untouched. There are things you can get published out there if you want to work on it. And there is life-saving treatments that you can work on, because these patients will go blind. I mean, if I show you a picture, it's just kind of gross, okay, of what happens to these patients. And I did that by going and looking under every rock to find patients anywhere I could go. Okay, and that's my take-home message about clinical research, at least. Leave no stone unturned. I did a lot of things that when I pitched the idea, a lot of people said, that's crazy. But at the same time, a lot of people thought Einstein was crazy. A lot of people thought that a lot of the foremost thinkers out there were crazy, But it's coming up with these inventive ideas. There are things that I follow the wheel and I say, this has been done before, I'm gonna go the path of least resistance. But sometimes you need that creative mind to come up with new ideas, and that's where your minds can come in if you guys want a career in environmental health sciences, clinical research, or in any of those fields, biotech, any of those things, okay? And that's all I have.
Any more questions?
Do you have cards?
I do.
Yeah. I want your cards. Well, thank
You want my cards?
That was fantastic. On behalf of all the students and
Oh, thank you.
programs,
Oh.
little thing to take on the road with you.
Oh, I appreciate it. Well, thank you.
Thank you. And if you leave your card.
I will leave my cards. Come by and get me. If you want one, I'll be sitting right there putting away my stuff. Can I get my USB thing? Yes. Perfect. Thank you, guys.
Thank you. Absolutely inspiring.
Here's the microphone.
Oh, thank you. So let's hope Christelle is here. Is she here? Oh, good. So usually what we do is every student interviews their practicum supervisor, and I'm sure you've spotted her in the audience. Did you conduct an interview?
I actually didn't.
Oh, you didn't?
No, he's actually not my supervisor.
Oh, he's not. Well, who did you talk to at Allergan then?
I talked to Elena from TELUS
Uh-huh.
in the RDCM department.
Okay.
I talked to you in the beginning though, so I guess we get a position.
Yeah, okay. Tell us, did you learn anything that we haven't heard today?
Just the overall phases of trying to get a drug developed is very interesting. I mean, I work in the regulatory documents and contracts management, so it looks like a different area as opposed to like single overview.
No, so there's the clinical research, the epidemiology division, the marketing, and this is regulatory policies.
Yeah, so
Yeah.
basically we manage the startup and maintenance of the documents that gets passed on between the company and the clinical sites.
Mhm.
So,
And how did your supervisor get to that level?
how did she get to
Yeah, what?
She told me that she used to work in a similar company doing the same thing. So when she got to Allergan, she knew what she wanted to do, and so she was able to get that position.
And so is there a lot of interaction with the FDA rules and regulations that we talked about?
Yeah, there's a lot of disclosure forms and whatnot. So we deal with that. Basically, we receive them from the sites and then we upload them to an online database thing so everyone can access it.
And what's your day-to-day? What's your day-to-day activity? With,
My day-to-day
yeah.
activities. I make binders that I send out to the clinical sites, and I also assist the clinical projects assistants into various secretarial tasks.
But you're learning the process. Good. Okay, thank you. So there was one question about the $1 billion and how much of that you give in grants to university researchers. But I think the spirit of the question was also, we all assume Allergan is so rich that you don't need to go applying to NIH to get grants to support your work. But
So we don't normally apply for those. Usually investigators do, and then a lot of times investigators will ask us to fund them, as if
Right.
we were like
the
them,
NIH, yeah,
if you will.
yeah. Probably
So
you're
they'll
richer
ask-
than NIH, they
Exactly.
think, yeah.
And it's a lot easier. You've
Yeah.
got less paperwork. Sometimes it's like, hey, buddy, can you help me out here if they know each other? And so, but a lot of times we will support them by either providing our product for free at least. And so partially it's funded by us, and then the actual grant is funded by NIH, but they get free product from us, so that way they don't have to waste the $50,000 grant on buying
Right.
product. So there's different things like that that
Right.
they can do. And sometimes we'll just straight give them, here's a grant of $100,000.
Go do the study. Now, some federal government agencies like NIH, EPA, NSF, they give what they call the small business grants. And I imagine some smaller pharmaceutical companies, startups, may benefit from that kind of award. So
Definitely.
it's not like you are excluded, it's just that you don't need to go that route. Okay. So last week we talked about some of the different practicum projects and thinking about writing your grant proposals, which is one of the assignments for the course. I asked you to think about a branch of NIH that might fund your work, describing the goals of that agency, what types of grants they've supported, and what are their priority areas. As we heard from the discussion today, there are so many priority areas with Allergan's products and the market that they serve. The other thing we like to do with each of the presentations is to think about the role of public health knowledge systems in their work. So the core areas of public health, and several of them came up in the presentation. So let's begin with epidemiology. What part of his presentation would you consider an epidemiological knowledge system is essential? Okay, cool.
Maybe when you're like phase 2 or 3 and you're enrolling patients that are diseased, you have to know where those people are located.
Right. Yeah. I also saw that in the very last part, the rare diseases, okay, that's a very strong epidemiological database, and recruiting subjects, patients to the study. Because if a disease affects less than 5 in 1,000 people, you'd have to know where they are and to go after them. So that's a very strong. What about biostatistics? Did he say anything that reminded you of why you needed to understand statistics? The p-values, right? 0.0001 versus 0.005. What about social and behavioral sciences? What aspect of Allergan's, yes?
Compliant in taking the drug?
Yeah. You can actually, according to you, patent a new way for patients to take their drugs more effectively. So if it's something that they have to take 4 times a day, it doesn't fit into many people's social and behavioral patterns. But if you can find a way to make it once a month, you will increase compliance. Are there diseases that compliance to take drugs is a huge problem? Why we still have that disease in our communities? Is there one particular disease that comes to mind? Yes?
Well, what we talked about maybe 2 weeks ago, well, it's not really, but like condom use.
Well, yeah, condom use and behavior change. But tuberculosis is a disease that's often cited because you have to take the drug for more than a year to clear the bacterium from your body. And a lot of people fall off. They start feeling better and they suddenly decide to not take the medication. The same thing with antibiotics and why we use them, sometimes for unindicated conditions. So there's a lot of behavioral stories with medications. What about environmental health? Was there anything that came up? Yeah.
or that some of the investigators will like test on themselves. But I don't know, that's more of a workplace environmental health.
It's also maybe social and behavior. Yeah, it's a major occupation and environmental hazard. But yeah, he didn't get into it as much. But phases 1 and 2, I'm sure a lot of hazardous waste. You did talk about environmental health and safety. And there's a lot of compliance with those policies when you're running any kind of lab. And I think that's a very, very important part of the process. Yeah. What else? Health policy and management. Anything jumps at you about health policy? The whole FDA thing is about policy. And who sets those rules? A lot of it is trial and error, but after many years it becomes set in stone as standards. And until somebody pushes the envelope, they come up with a new drug or process that doesn't fit the previous regulations, and they change it. But a lot of it is also to protect the public, to make sure that drugs that are not effective or that are not safe don't come to the marketplace and cause harm. There is a lot of concern and debate about whether FDA should be regulating, for example, food additives as they regulate drugs. I mean, you can go to the Mother's supermarket and buy all kinds of things that will say not FDA approved, and people take those things at their own risk, but there is a lot of the social and behavioral issues around what you believe to be working, the placebo effect, which we didn't talk about, but it's also very important, recognized by pharmaceutical companies and physicians, is an important part of the whole process of approving a drug as a good cure for a particular disease. There are several cross-cutting themes that also came up. One cross-cutting theme that's not on our diagram is ethics, but I always want to bring that up. So what aspect of this talk struck you as an important case study in ethics? Yeah.
Well, the one positive example he was giving about Vioxx, right, where they knew, they knew really there was other drugs out there that were better, that were healthier, safer than theirs. So even though all these places were saying, we want to keep your drug on the market, they said, no, it's not right, we'll take it.
Even if the money is there, they were.
The right thing to do.
Yeah, so moral values and ethics is important. Social, cultural diversity stuff. What about that? It's a cross-cutting thing. Cultural sensitivity. Nothing about Allergan brings out cultural issues, diversity issues. Diversity for sure. Maybe we don't call it cultural. Yeah.
Looking at the different policies in different countries, and also looking at how each product might react differently with different kinds of people as well. So.
Right. I think we should think of diversity not just as ethnic diversity, but the international issues also come to play as well. What about this is gender, but men will not be using a lot of Botox, perhaps. And so, or the eyelashes. Maybe if you come up with a bald spot. So there are these, diversity issues and culture issues that are not just about ethnicity. It's also gender and international aspects. What about communication and informatics? Let's pick communication. Yeah.
Just when you're doing working with IRB, when you're marketing the study to the public, and how you're enrolling patients, you have to use certain fonts and everything for the study.
Yeah, not just the physical way you present information, but many times in his presentation he talked about convincing FDA that you have the data. Hundreds of thousands of pages of communication between the company and FDA. Somebody has to sit and write very clearly what the company is trying to do, why it will be a benefit to public health, and what FDA's responsibilities are in giving them prompt feedback and hopefully fair review. So a lot of it is actually focused on that aspect. What about the biological basis for public health? I mean, that's kind of obvious. It's everything. You have to understand the physiology, the toxicology, and the mode of action of many, many drugs. So that's very, very useful. We could go on and on about, but you know, it's such a loaded presentation with respect to all of the core and cross-cutting themes in public health. What I wanted us to do in the time remaining is to just hear very briefly from a few of us, and this is also how I take notes on who's here and who's not. Tina, do you have a sense of what NIH agency might help your work? Okay.
I haven't looked at it yet, but I was going to do something about child development.
Yeah, National Institute for Child Health and Development, NICH. So you should look at it, and next time we'll talk about what you found out, okay? Christopher? Not here. Cecile? Yeah. Okay, you see these questions? Yeah.
Okay, so I work at Crystal Vision Optometry, and I've asked the doctor about whether they have ever
Written grants?
done anything with grants, and she says that they don't. But I was looking up some places, and there's the American Optometric Foundation. That's like one of the biggest ones. So I was gonna.
They might, but you should also look at NIH's website and figure out which of those branches will be able to support it, okay? Rochelle? Yeah.
I work at, or I volunteer at elementary school. It's basically Disney Goals. It's located in Huntington Beach, where it's a low-income type of, it's centered in a low-income type of community where they do after-school enrichment programs for children.
Mm-hmm.
And basically, maybe I could just look up like, and the main thing that the program struggles with is funding from the city on supporting like their programs, because the kids do all these things for free. Like, they get like art lessons, they get field trips and everything for free. So I'll probably just look up something for some kind of grant proposals to help.
Yeah, so it is child development.
Yeah.
So it's same as NICHD, National Institute. Okay, thank you. Sohar? What do you do at the Dean's Student's Office?
I'm sorry?
Yeah, yeah.
So I specifically work at the Veterans Center here on campus. So they don't really, haven't really done any grants. But I talked with my supervisor, and then basically she told me that like program implementation of like, I was just like telling her about an idea for my grant proposal could be like holding like workshops or like classes for veterans, like to help with the transition process.
But what would be, what would you be trying to improve?
For psychological.
So it's National Institute for Mental Health.
Yes.
Okay, so NIMH. Next time I'll call on you to tell us about NIMH. Okay? Jeffrey? Yeah.
I'm at the Center for Behavioral Sciences. So
Mm-hmm.
we just generally just take care of like autistic children. So I was thinking about doing, I haven't looked too much into it, but I was thinking about doing my grant proposal on the neurological
Mm-hmm.
disorders and stroke. Or child development. I'm not too sure yet.
Right.
But
Either one would work, actually. Yeah.
So yeah, I haven't looked too much into it yet. But
Okay. It's a good prompt to look into it. All right, so there are several other funding agencies, not just NIH. You've all heard a little bit about people considering those other sources. I think it is important that you all be familiar with NIH, because in terms of university research, it's the most likely source of funding. But the nonprofit organizations, the Bill and Melinda Gates Foundation, Robert Wood Johnson Foundation, not governmental agencies, American Diabetes Association, Autism Speaks. They also fund research, and pharmaceutical organizations, as we heard today, Pfizer, Allergan. They all give out small grants, either financially or in kind, to support work. And the rest of the slides that I have here are really to introduce you to some of these agencies that may be places where you might target your grant proposal. So the Center for Disease Control and Prevention, they're very busy doing the actual work, but they don't know it all, so sometimes they do support faculty to go out and do research, or they donate equipment. I remember once when we were trying to study blood lead poisoning, they gave us the instrument that we took to the field to document the incidence of lead poisoning in children. They have several goals throughout every stage of life. They look into healthy places in terms of environmental quality. They are the best sources of expertise in the world for emerging health threats, especially infectious diseases. They're always all over the world looking for emerging pathogens, and they are interested in global health under their Healthy People in a Healthy World program. The Global Forum for Health Research is based in Geneva, right next to the World Health Organization. And their goal is mostly to correct what they call the 90-10 equity problem. Essentially, they work on those orphan diseases that Dr. Doan talked about. They are more concerned about making sure that the 90% of the population in the world who suffer the 90% of the burden, but with 10% of our expenditure on health is trained to solve those kinds of health problems. So they try to correct the equity issues. Every year they have a forum, and they do engage students. They take applications from students to support research. I think they give up to $20,000 to support student research if you write an essay to them. So their website is very accessible and very straightforward. But these are their priorities. If you're interested in working in low and middle income countries, creating equitable health systems, or other kinds of priorities in research for health, that is the place to go. The World Health Organization itself, it's funded by donation, believe it or not. So countries donate money to WHO, so they don't have a lot of money to give out, but they are welcoming to ideas that will improve their mission. And every year they meet at the World Health Assembly, it's always in May, to map out what the priorities should be for the following year. And as you see on this list, the priorities: blindness and visual impairment. So you are working on the crystal vision. That will be, I would certainly go to that website and click on what they're doing on blindness and impairment. Disability and rehabilitation, electronic medical records, which is the e-health, the Millennium Development Goals, neglected tropical diseases, many of which are huge burden. They're not necessarily orphan, but it's because it's very difficult to create medication for countries where people are poor. How do you make your $1 billion back if you work on medication against diarrhea, for example, where it's not a problem for the US or the Western world, but it's mostly a problem for developing countries. So that's another dilemma that pharmaceutical companies face. And then non-communicable diseases. Dr. Margaret Chan typically heads the meeting, the assembly, and she's responsible for implementing the priorities. And then Gates Foundation, it's one of the richest sources of funding for research and implementation of public health programs anywhere in the world. they fund nonprofit organizations. They don't give money to individuals, so you have to apply as a representative of the university. And their priorities, there are 4 areas: global health, HIV, malaria, TB, diarrhea, development, water resources, and nutrition. And within the US, they really focus on health education and in terms of policy and advocacy on tobacco control. Another foundation is Robert Wood Johnson Foundation. They really just do US-based issues. They don't really go far outside the US borders. And they are very interested in these areas: health policy, prevention, cost and value, and leadership. And if you click on those sites, you'll see some of their priority areas. They're very big in funding anti-smoking, lung disease, cardiovascular disease type work. Here are the places where they funded work. They spend almost $400 million every year in terms of grants in 7 areas. And a lot of that is in California and on the East Coast, typically New York, Massachusetts, Connecticut area. So it's also learning about these opportunities is an important skill that you cultivate as you enter the workforce, that you are knowledgeable about the places to go to get grants for some of the agencies, such as the ones represented by your Practicum sites. Okay, I think that's about all. Those are just examples of places that fund the kind of work that you're all doing. The final version of your op-ed is due tomorrow. Are there any questions about that? Yeah.
Will we find a foundation to support the grant?
Right.
Does it have to be like an actual, like a proposal that they actually have open, or as long as it follows a mission?
No, you should just write. The idea is to find the agency that might support the grant, but you don't have to see that they're calling for proposals in that particular area. Okay. Any other questions? Yeah.
Is the article, the final draft for our article due also tomorrow?
Probably, yeah. Yeah. Yeah, everything that's due tomorrow you should submit. I wanted to, because this is a final one, I want to make sure if there's anyone who has questions about this. Yeah.
Scholarly article review.
Yeah.
I that they were trying to extend that to Friday midnight as opposed to Thursday the same night as the op-ed.
I thought that was the last week's one because the Shar told you something differently, so he extended it to Friday night.
He said that he was going to do it this week.
This week.
He wasn't able to get back to us on our
Okay. I know he sent that email to you all. Did he send it as an email? Okay. I'll clarify with him. Okay? All right, well, thanks to Dr. Lon again. Yeah.